Nice. Okay, I see it here. Thanks for letting me know. Or else, like, I had to redo everything. Okay, perfect. Now recording is on. Okay, so today's session we will be discussing about what is software testing. Then following that, we will discuss about some history of software testing and why software testing necessary. Plus, there's something called software development lifecycle. So, what is software development lifecycle? And there are different methodologies, uh, which by which we have by which any software company follows their process to develop an application. So there are different methodologies like waterfall methodology, V model methodology, iterative or agile methodology. These three are very famous. There are few more, but these three are very famous and we would be using them. And then we'll go through what mind of software tester, like how a software tester should be thinking, or like what are the steps they should follow while testing. So that, and then following which we will see some principles of software testing. Like, yeah, there are some principles which we have to follow while testing an application. So let me open my notes. I think Zoom has its notes as well. So um, I wanted to open their notes. No, I had it open, but now it's closed, I guess. Generate remote chat participants. Where is notes? Mm. Okay, it's not there. Anyways, I can use my notepad. So first is use this to see. What is it? Okay, let's start with the session, which is what is software testing? So before going into software testing, let's try to review some of the uh, history of why software testing came into picture and since when. So back in like 19, I mean the software firm or like engineering term was initially devised to uh, for hardware stuff. So while building a car or while building an machine and things like that. But uh, slowly programming or software came into picture, which was used to control these devices, right? Like all these heavy machines and everything. So early 1960s or 1970s, I would say. Uh, that was the time when there were a lot of physical machines and there were less number of softwares because like people were not very much informed about like software part of the engineering and and then that caused like a lot of issues. So there were more demands of software engineer and there were less number of software engineers. Uh, and that's when the term of engineering came that, you know, even software has to be designed and developed. And hence we started calling like software uh, person who learns software as like engineers. So that's how the term software engineering came into picture. And and all the courses of programming started coming into play and people started learning like different languages of softwares and started building like more and more software which in term which in turn like helped these machines to perform like better. So imagine like a car, or like if you go back to like 1960s, 1970s or 80s, you would see that there was a lot of manual things, like even rolling down the window, you would use like a handle. but now that is replaced. Not now, I mean, like it was replaced long ago. So by using the machines plus the software together, where like the machine would be operated with the help of software. So software is nothing but like a program which tells machines what to do. So that's how like the software engineering came into picture, and it kind of uh, made our world like made everything easier. So now, why do we have like why do we have testing? Why is testing required in an application, right? Uh, why do we need testing? So the major requirement for testing is like to find any defects in the system. Okay, so find any defects, as in not just to find defects actually. There are more to it. So, but the for being a software tester, the main thing which you have to do is to ensure that the quality of the application or even the system or beat anything. So like testing is required to make sure that the quality of the product or application or software is good. Is good as in like someone can use it with ease, and someone can rely on it, uh, and someone can trust uh, that they are providing information is not being lost or something like that. So software test, so that's where the testing comes into play, where uh, the quality matters, that could impact uh, the because in turn, like if the quality of an application or product is not good, it could impact the company in turn. So, for example, I would say there was a company called Nissan. I mean, it's still there. Nissan is like one of the car manufacturing company, and they had to call out like around 1 million units of car just because their airbag system was not properly working. Why was this happened is the testing was not completely done for the application of or like the of the program part which triggers the airbags to open. So this was not properly tested. There was some incidents which proved it that the car does not work, or the airbag system does not work, and that costed Nissan like millions of dollars, because they had to get back all the units and replace this unit and then give it back to the client. So for a company, it's like reputation, right? So if the application or if the product is not with high quality, it costs company its name and fame both. Uh, so that's the reason we have testing into the place. Be it like testing in any domain, like be it like mobile testing, be it like web testing, be it like any industrial testing. So testing plays a very important role to make sure that the quality of the application or product is perfect. So yes, and there are two things about the quality. One is like quality assurance. The second one is quality control, right? But before even going to this, I forgot to mention one thing, which is like journey, journey of QA, quality assurance. So when you join the industry, like how you guys are planning to currently, uh, learn everything about the software and then join the industry. So how is the career path of quality assurance engineer, right? So any company first, like if you don't have any experience, you would join as like a junior QA in that company, where and the salary range for junior QA in Canada at this time is like close to 50K, or around like 40 to 50K, nothing more. Uh, then you would move to like, if once you have like a couple of years of experience, then you would move to intermediate QA. And I think in Canada, when I joined, like the salary of intermediate QA was like somewhere close to like 60K. And then you move a little bit up, like you have like around 5, 6 years of experience. You become like senior QA, or sometimes like even the lead QA, and salary for them is around like 75K and above, and then you become like QA manager, and salary for them would be around like 120K. But to be QA manager, you need to have like around 10 years of experience, and then you would have for in those 10 years you should have little bit of QA lead experience, so maybe like 3, 4 years of lead experience, and then you can make this. So this is how the journey of a QA team member looks like. Um, Going back to since you have joined like in busy QA, where they are going to give you a work experience letter as well while you are learning. Um, so that would take you away from this list of junior QA, and you could directly apply to jobs which is for intermediate QA. And again, so the testing has like different. So there's manual testing, there's automation testing. So manual part of the testing is paid like a little bit less compared to automation part. However, uh, if you are a good automation engineer, you could easily make somewhere close to like 80 to uh 80 to 85K per annum for automation QA. And again, automation means like you need to know uh, different automation tools, uh, different automation tools, as in like you should know, you should have like a very good base of one programming language, plus you should know various automation tools. So that's how it will go. Um, then yes, so this is the journey of QA. If you're ever imagining like what would how your career would look like in IT industry or in software industry, so this is how it will be as a QA. So I hope that you learn as much as possible from this course and get into the market and at least get into this zone as soon as possible. So maybe in like 3 years down the line, 3 months down the line. Sorry for that. Okay.
Sorry,
Uh,
can I ask a question?
yeah, yeah, sure. Yeah, if you have
Um,
any question, please do ask me so that it doesn't feel like I'm just talking. It will be really nice that if we interact with each other that way. Yeah, please go ahead.
okay. So I was wondering, thank you for breaking down the career progression. But I
Mm-hmm.
was wondering, in terms of longevity,
Mm-hmm.
obviously we know like AI has the ability to replace many roles,
Yeah.
but I was wondering how if that's also a possibility with automation because it kind of seems somewhat, but you've been in the role for a while, so I think maybe you would have a better understanding on how it would like how the possibility of it being replaced by AI.
I don't think so. There's like high possibility. So AI would make things easier, like if it's programmed properly. So given like if an application needs to be tested, so AI would make it easier. But again, AI would not do the job for us. So there's still uh there is still or there will still be a need for a person to validate what AI is doing, right? Again, AI is again nothing but like a software application which is performing whatever is instructed. So what is software? To be honest, it's like a program code which a human has written, right? And humans tend to get into an error. Uh, and if we have like an AI which is going to do the work of a human, so again, there is high possibility of AI getting into or AI not catching all the defects. So I would say that QA or like QA jobs will always be there no matter what, no matter how many AIs come up. It's just that with the help of AI, imagine the job which we were doing in like one week, it could be done in like 3 days. So the only um, help which AI will do is like it will help in some processes for us. That's it. But it's not going to take over anything. So if you learn automation plus you know more about like AI, then you will be standing high. I would say you would be in a better position to than the people who don't know automation or AI. AI as in like just know how to use the prompts in ChatGPT and stuff like that.
Thank you.
Yeah, I hope I answered the question. Yes. So it's again like how machines evolve, right? Like imagine this is how I see it. I could be wrong, but and there are different views also. So before sewing machine, like which is to stitch clothes, came up, like all the tailors were stitching it from their hand, and when the sewing machine came up, like it definitely boosted the business by like everything was faster and there was like more products out and like more clothes were manufactured and things like that. So in this phase also I feel it's the same. So if we try to upgrade and if we try to use ChatGPT in a good way, where like it enhances our skills, uh, where like if you're trying to type an email, which will take around like 5 minutes for you to type, and if you use ChatGPT for do that, it will give you a template which you can use it and do the work in like 2 minutes, right? So it's just the way of how you see it and how you use the application. So it will just ease your work, but it will not take away the work. And this is how I see it. So yeah. Okay. Any questions so far? Okay.
Yeah, it's clear.
I'm still very new to this Zoom thing, so I have no idea how everything works in the Zoom. Maybe it will take like a couple of sessions, and then I would know uh everything about the Zoom as well. I mostly use like Teams meeting or like Teams stuff, or even Skype, but Zoom is like new for me. These guys they had like a note, but I don't know where it is. That was very interesting. Okay, anyways, let's go out of that and concentrate here. Okay, so I have told why is software testing. So what is so we have cleared the history. History is done. History is like why and how we got here of software. Okay, let me see. Because I don't want to be lost from the coursework itself. So okay, software testing. So now, what is software testing? So software testing is nothing but it's a process for evaluating a software product to find whether the current software product meets the required condition or not. And the testing process involves like evaluating the features of the software product for requirements in terms of missing any requirements, bugs or errors or security, reliability and performance. So software testing is like and so first is I'll take you through what happens or the process and process of like software development completely, and then I'll explain like what what we would test and how we would test, and yeah, things like that. So because if I follow this material, uh, I would be giving you more information. If I follow this material right now, I think I would be giving you some information without telling you the design or the process. So I would take a different approach, tell you what happens in the software testing, and then we would come back to like why software testing is necessary and stuff like that. So I will start with this. Okay, for any software DEVEL development process, first is the requirement. So requirements is nothing but uh, what are we going to develop, or what product are we going to develop. So like product or software application which we will be developing. So who does this? So like all like stakeholders here would be like business analyst. What these guys will do is like they'll all the business analysts and the business people, they'll sit together. They know that they want to build an application or software application. So for an example, we'll take like um Instagram. So while Instagram was built, like there were like few people who were like, okay, this is something which we want to build, where we want to build an application where people can store in their photos. They can make their accounts. They can store in their photos, and they can send like a friend request, and people can connect, and things like that. So what what whatever the application is going to perform, so those are nothing but the requirements, and all the stakeholders for this would be like business analysts, would be like the business heads, and these guys will come up with a problem statement or the product which they want to build. So uh they will all come together and list down all the requirements which an application needs, and they will give those requirements to business analyst. And what business analysts will do is like business analyst will prepare uh, a document called business requirement document. Okay, so what this document will have, it will have like the objective objective of the project. Then it will have like introduction to the project. Then it will have a scope of the project, uh, and even out of scope, out of in scope and out scope, project in scope and out scope. Then it will have the functionalities, functionalities of the application, what and all it's going to do. So for example, for Instagram, it will like, for example, create accounts, uh, upload pictures, then yeah, likes, comments, connect with other users. So something like that. So this would be the functionality. Um, then it would have things like so these are, yeah, so this plus they would have um, business, they will have like the references from where these they are getting these, or like if there are some charters and stuff like that, so they will have like references. They would have yeah, I think there are a couple of more sections which I'm missing here, but yeah, that's not the point. The point is like first thing would be business requirement document, which business analysts, stakeholders, they come up together, and then they kind of have a lot of meetings to decide like what the application or product would do. So, and that is documented completely in a business requirement document, and this would act like a very key role for both developers and testers in the project. So first, a business analyst will have the requirements document, and then they would send this requirement document to uh, development and testing team. So it will first go to developers or development team. And who would have this BRD? It's like the architect, solution architects. So solution architects are like people who would do a high level design document, where what they will do is like they will create like a high level document which would say okay, these are the functionalities. How can we achieve all these functionalities, right? So they will, so for this, it would need like a table or like in database, how the database should be designed. So UI design, DB design, workflows. So workflow as in uh workflow as in like a for like a user can't go and directly add a picture for like Instagram example. So first they have to go create an account, uh and then they have to go and upload their pictures or whatever. So this is like a high level design which a solution architect does, which is like creates like a UI design as in like what UI would look like, what UI will send to DB. DB is nothing but a database which stores all the information which we it has uh, two things to do. DB, one is to store the information what user is giving, and the second one is to give back all the information which user is requesting. So you from UI, user can send the things to DB and then again retrieve everything from DB to show it to user. So that one plus the workflows. So a solution architect will be responsible for doing all these things, and solution architects would put all these things into a document which is called high level design document. So once a high level design document is prepared, we would move to the next stage, which is to prepare. So high level design document would not cover each and every functionality. It would just be like a overall design of how the system or like how developers would like it. Developers will take all these small parts or like this each section and then divide it into sub modules, which is called low level design, which will be like even in details of each and every section about this, maybe UI design or database design or like workflow design. So that will be in low level design document. Okay. And this is again done by development team. So once both this high level design document and low level design documents are prepared, developers will start to write the code or start programming, which is called like the coding phase, where developer will write the programs and they will do a unit testing. So unit testing is part of development team where they test all the code which they have written. They will not complete like 100%, but they will still try to complete like or test the unit completely. So once each unit, so imagine like a UI is designed and then DB is designed by some other team. So what happens here is like designing one unit is like one small section of of uh, of the application. So first unit is designed and then this unit is integrated with other units. So maybe like UI is designed by different team, DB is designed by different team, and now after designing or programming, they have to interconnect these two teams. So, or these two units. So then comes like integration testing. So first is unit testing, like each section is built. Then comes like integration testing, which developers will do to test like if two different systems are not different system, like two units or like modules, when they connect or when they are connected with each other, it's doing everything perfect, like how it was working with unit testing. Unit testing, I think everything is just test. By unit testing, I mean like module which is tested. Um, by running the code. So they will integrate this. Imagine that there are two units, right? So when they both are integrated, uh, to give an example, I would say imagine that like uh, one user has like different uh, again Instagram example I would say. So there is like one user with one account and uploads a photo. There is another user with one with their own account and uploading a photo. Now when these these guys are connected to each other, and then they can comment on their picture. So what happens here is like these two are integrating. So like there are two modules which are being integrated. So one is like the account module plus the comment section. So like this is like integration of two different modules, and they have to make sure whether the thing is working perfectly or not. So that is part of integration testing, uh, and developers will do all this part. So we have covered two sections, which is like first one, all the business analysts and stakeholders will do the requirements part. The second is development team who would build the architectures, who would do the coding of the application, and then they would also do unit testing and integration testing. Then comes us, which is like software testing or testing team. We will be given the BRD, which is like business requirement document. It's called BRD. Sometimes we are given uh, this high level or low level design document, or like functional specification document, you can say. Functional specification. Okay, so we will be given these two documents, and what we have to do is first go through each and every section of the BRD and see what the application is all about. Try to come up with a test starter test plan, and this would be done by like the QA team lead or team manager. What they would do is they would go ahead and create a test plan. Test plan is like a document which will have sections like what are we going to test in this application, right? Um, so it will have like the objective of testing. It will have objective, again same thing. So objective, it will have like the introduction to project. It will have like scope of testing, what are the functions which we are testing, and outscope. So what are the functionalities which we will not be testing, and then functional testing of what and how are we going to test that. So each and every functionality will have a section. This test plan document I would go over in next week, but I'm just giving you an heads up of how this document will look like, plus what are the tools we are using to test the application, plus what are the resources, the time required, uh, and then approvals. So yes, I forgot to mention the approval part in these sections. So each and every section has an approval part where even for the requirements, once the requirements are documented into business requirement document, business analysts will go to the stakeholders. Stakeholders are like uh, uh, what we say, boss of the company or like the business people. So business analysts will go to them with their objectives and like BRD document, where these stakeholders will review the document, say, okay, all the functionalities which we want for the application is present in this document. Go ahead and we approve this document. So they sign off the document, they approve the document, and then this document is sent to development team, where they make the high level design document, and then again those documents are reviewed uh, by their senior members or the business analysts and stakeholders, and then it will be passed on to the next one after approval. So again, when developers do coding, after writing their unit test or integration, after writing their unit uh, code or like integration code, they would have someone to review their code first before it comes to testing team. So to make sure that the application is doing what it was designed. So developers will also have a development lead who would go through these changes and then send it to our testing team, the entire code. And on the other hand, what testing team has to do is like it will go through a business requirement document. it will first, and all their managers and leads will create test plan on how we are going to test the application by itself. Uh, so create the test plan and then identify the resource who would be testing the project, right? So then they would assign this test plan plus the BRD document to test engineers. So now what test engineers will do is like they will go through BRD and functional specification, FSR, requirements or FSD, and test plan. And they will create something called test case or test scenario or test case document. Okay, what happens here is like for each and every functionality which is present here, there has to be some test cases. So test engineers will go and create a test case document where each functionality is taken from there and some test cases are written. So again, these test case things will come in the next session. So I don't want to go a lot in detail here. But yeah, so this is the steps. Like these are the things which will happen. So um, I'll just give you a brief intro on what this test case document will look like or what it will have is. So imagine that we are going to test one field, uh, which is like uh, uh, which is like a name field. It takes only name as an input, uh, and it should not contain any numbers. So you would write test cases to test this field itself. So like your positive test case would be write a name and name should be saved successfully. Your negative test case would be um, that try to input some numbers and it should not be saved or it should throw up an error. So that would be your negative case. However, if your system is allowing to put your number in this field, then there is a problem. So that will follow a different life cycle of defect. But these are the steps or the scenarios which you would mention in the test case. So there are both positive test cases and negative test cases which you will be writing in this document. So this is nothing but creating the document, and next is execution phase, test execution, where our testing team will. So we have our test cases created, we have our coding completed. So now what we have to do is like start testing the application. Resource, okay. So we have testing team who would start testing the application. Since they have made the test case documents already, they would go through each and every test case and they'll have the application open. Test case document would have like the steps and testing team would go take one test case from the test case document. It will try to perform those steps into the application. So a very simple example is like uh, open the Instagram application, create new account, and make sure that the account is created. So this is one of the test case. So what and this would be the steps. So testing team member will go take the first test case. And they will execute the test case in the browser or in the phone or wherever they want to, and take all the screenshots and make sure that the uh, flow is complete. So that happens in test execution. And yeah, test execution has like two parts. First is test application, and testing team is responsible to execute the test cases. And I hope now I'm clear about like what execute means here, which is nothing but like open the application, do the steps which was written in the test case document, and see if it is meeting the requirements of the test case. So yeah, testing team will execute the test cases. Will stop, and then comes deployment. There is defect also, defect management, but I don't want to go over that at this point. I'll tell more about this either today afternoon or next section, defect management to be discussed later. Okay. So now once we have tested all the application, we will say uh, test exit by signing off. So once all the test cases are executed, what we would do is we will say, okay, uh, we would say, okay, now application is working as it was designed by BA, and we are signing off that, everything is working fine. It can go ahead for deployment. So now after which is deployment phase. Deployment phase is nothing but uh, the entire software or the application is deployed onto a server, and UAT people, which is like business people or the users, will start testing. So which is called user acceptance testing. So here, so first phase is user acceptance testing, and the second phase is deployment has like two phase, and the second one is like production, real time user. Yeah, so deployment has like two phase. One is like UAT. So they will deploy the application for some users to test the application. I think like imagine like first time when Facebook was introduced, or first time when Instagram was introduced, it was not directly given to everyone. It would for use. It was first given to some users to see, and to see if they are liking it, if all the if 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 the usage of application is simple, it is doing what it was intended to do, and things like that. And then finally, once user acceptance testing is done, we see that application is very stable. It can handle a lot of it can handle all the scenarios which users are trying to perform. Then final stage would be to put the code into production. Production is like real time. So production is like the server where uh, everything happens in real time. So for example, you have your banking application. So those are in production right now. But banking, like I'm with Scotiabank. So I have like the Scotiabank application, which I can use to do my transactions and everything. So right now that is in production phase, but even these applications went or followed the same structure. First, there was a business analyst, then development team, then testing team, and some user acceptance testing, and finally the production team, which is like real-time user, and users will use this application at this point. So do you have any questions or any concern on the process of, how software requirement happens, or like development or testing or any stages? So is the stage clear on what would happen in like real time?
Yes, for my
Okay.
end.
Yes, yeah. But
Okay.
Yeah.
I do have I'm curious about something though.
Yeah, sure. Go.
Uh, for the UAT, the user acceptance testing,
Yeah.
does that also include like beta versions of apps? Because
Yes.
BMO recently changed their app and they just sent like a beta version, and then after that they actually
Oh,
sent the actual app.
correct. There is like two phase of testing. One is like alpha, and another one is like beta. So beta is alpha is performed by, maybe like imagine that there are two parts, there are two people or two groups of people who will do the testing. So alpha is something where imagine that Instagram has their own people, own set of people, which is from their own organization. So they are called like alpha people. So the organization people will do this testing first, and then they will pass it to like beta testing. Beta testing is like rolling out the application to outside environment where like people are not from this organization. Uh, so for Scotiabank example, when they release out their beta, they will release it out for external users like us. But for alpha testing, they would release out the application only to people who are working like Scotiabank. Okay, does it make sense? And that's why you
Yes.
see, there'll be like a lot of beta version application which you will be using. Even like if a programming language is first developed, it will have like a beta version to make sure that when users are using it, it is not breaking everything or it's not breaking anything. So that is the purpose of beta first, and then we release it to entire user. Uh, because if the application has problem and if it does not go through these two testing, um, then users might not like the experience. Imagine like there is a problem with some transaction in Scotiabank. You try to send some money and the transaction goes to error, right? So if beta testing was done, someone would have done this transaction before, and uh, this issue would have been caught earlier. But since this was not caught and it went to the real-time users where many people are not doing the transactions, and that has like a high impact. So first is it will impact like the company, um, that Scotiabank is not performing good, as in like their application is not good, and they might lose customers. So that's like an impact, like it will have like a big impact. So the more testing any application goes through, the more stability it will have and the better quality it will produce. Okay. So I think it's good. I think at this point it's better to take a 5 or 10 minutes break, because I think I have loaded with you guys with a lot of information. So let's take a small break of like 10 minutes and then we can come back. What's it?
Thank you.
Okay. So I'll pause the recording for some time, or else my this thing will keep going on. Where is this? Okay. Okay. You can see my screen now, right?
Yes. Yes.
Yes.
Perfect. My notes. And don't worry about making the notes. I'll be passing this around uh, along with by the end of the session. And also I also have one PPT which I'll be sharing with you guys at the end of the session. So you can go through that also for more information. So now coming back to this. Okay. Here are things starts, fundamentals of. No, I'll just write ST instead of software testing. I don't want to write like completely. So first is what is software testing? I would say it's so what we do in software testing. So we try to make sure that application is meeting all its requirements as stated by business analysts or in business requirement document. So it's a process where we are verifying that the application is meeting all the requirements stated in these documents by running tests. It could be manual tests or it could be automation. So manual test is like manually uh, opening the application, performing some steps, testing the application, or it could be like with the help of automation where you run some scripts. Scripts will do the parts, or like scripts will try to uh, impersonate you and execute those test case, executes those steps as you would execute. So that would happen, and in by end of the software testing phase, we have to make sure that all the requirements are meeting. There's no defects. Um, defect as in like there's no functionality which is not working, and and yeah, so yeah, quality has to, and this all in turn makes like the quality of the application little better. So Next would be why. Why is software testing necessary? Okay, the first thing is imagine a very real life scenario, which is an application is developed uh, and it's into the market. So users are using it. And imagine the application has gone through less testing or like no testing at all. Users would start using it. And since these programs are made by like a human being, right? There's high chances of uh, error to be present in the system. Errors could be because business requirements is stated in a way, um, or business requirement would say something, and uh, the developers would read it and understand it into a different way. So it could be due to the confusion or like the way business or the developer would have understood the requirement as. And there would be like misalignment between business and developers. So that could also create functionalities which are not as designed. So that would be one case. That's why software testing is required, where testing, where a software tester would go through the requirements, try to understand it, have any question, ask it to business analyst, get everything into correct mind space, and test the application, right? So problems which could be created due to developers by uh, by not understanding the requirements completely. And if that is given to the market, where people, when they start using the application, they would face an issue. So for this, I'll take a very easy example, which is like let's let's take uh, let's take Scotiabank application for now, because I think that's an easy way to explain for me at this point. So imagine uh, BA wrote a statement that first name, or when an application is open, a user should see all the information about their bank. And developers, while interrupt while coding or while developing the application, they would just display the name and the account balance, uh, and not everything. So uh, however, like it has to be very little bit descriptive, as in like from BA side. But if there was some misalignment where BA didn't mention everything, then QA on the other side would be able to see this application, see this business requirement document, and say like, what do you mean by what do you mean by see information on the main page, like what are the information do you want to see. So on those basis, like QA can question like BA, and BA would again answer like, I want first name to be displayed, last name to be displayed, account number to be displayed, address to be displayed, phone numbers to be displayed, and the account balance to be displayed. So this is also required, because imagine that BA in their head would be thinking, okay, I want all this information, but they wrote only like some, and developers understood and gave only one or two details in the landing page. And if,
I'm sorry, sure. I have a question.
yeah.
So, like for example, in this instance you gave, if they wrote only maybe the price or like only the balance should be there, but is everything that the QA looks at is based on the project charter, right? Like I don't like, like if you are saying, like if in the charter it was only price, or it should only be account balance that should be shown, and maybe the developer adds maybe some extra um functionalities, that means it's wrong based on the charter. Like what the QA does is strictly based on the project charter and what the BA people say they want, right? And it doesn't do no more. That's my question. Like, Is it
Yeah,
just based on?
that's
Okay.
true. Developers would do what is written into the document, but what I'm trying to say is sometimes they tend to make some assumptions. They try to make some, so developers would read the document the way they feel like. So they have to follow the requirements completely as per the charter or the BRD. Charter, again, since you have said the word charter, I would like to say that say what is charter to the team. So charter is nothing but document which is given by stakeholders, which would state. So imagine that there's an already a project which is present in the system. So there's a little bit of advancement which is required into the present application. So what stakeholders would do is like they would create a charter document. Charter document will have like uh, so imagine that there's an application which is already existing. They would want to add one or two functionality into the application. So that time charter comes into the picture where stakeholders create a charter saying that these are the requirements we want, and then it is given to business analyst. So what business analyst will do is like it will business analyst will take this charter document, take the functionality which is required, and then they will convert into business requirement document. So charter is like a small version of whatever the changes required, but business requirement document will be like a bigger document which will say, okay, there are these new two functionalities being added. What is it affecting, which is like scope? What is it not affecting out of scope? What are the functionalities which are being added and things like that. So then it becomes like a business requirement document, which developers will use it for development. And now coming back to the question of Adi, which is developers have to definitely follow BRD document where like whatever is written in the BRD, they have to close their eyes and program it for sure.
Thank you.
Yes, so that happens, and like if what I wanted to say is like from my I just wanted to create or give an example of uh, what would happen if a developer takes the or makes an assumptions while reading the requirements document. So they would in turn end up developing something based on their assumption and which is not present in the business requirement document. That's what I wanted to say at this point. Uh, just a second. So I think Anita is with us right now. I have admitted her. So hi Anita, can you hear us? Participants. Uh, Anita did join, so I just wanted to give a brief introduction from her.
Hi, Shrikant.
Hi Anita, how are you doing?
Yeah, good.
Okay.
Hi, hello, everyone.
So,
Hello.
Anita, will you be attending the session or you're here for like a quick introduction?
Just to give introduction, and for some time, I would like to attend the session too. Is that fine?
Yeah, that's completely fine.
Uh,
Sure. So, as you all already know that, Anita would be a person to go to during weekdays. So, yeah, so Anita, can you also like while after your introduction, can you also let us know whether like this was a question from Addy also, and I wanted to ask you whether on which days you would be available, plus like what times would you be available for any questions or queries?
it's from Monday to Friday evening, 6 p.m. to 9 p.m.
Okay, you'll be present all the days, or you'll be just present like 1 or 2 days?
It's like 5 hours per week.
Mm-hmm.
So, but during that time, I will be present.
Okay, perfect. Sure. Yeah, I'm sorry to disturb you, and now you can go ahead. You can introduce yourself.
Yeah, hi. This is Anita. Like, I will be your lab support specialist, who will be assisting in the coursework or assignment given to you by the instructor. And then any problems while downloading the software installations, etc. So you can just send me a mail whenever you have any doubts on that. Um, yep, this is about me.
Thanks for that. We have like currently we have three team members with us. One is Tommy, Salim, Addy, and they have joined us like for automation course. And first 3 weeks we have only them, because there are 3 more who would join us after the first 3 weeks, of which would be like for complete automation part. So at this point, Anita, I'm planning for uh, like all the 6 team, all the 6 students to have the applications installed in our system. So that on the week fourth, when the automation uh, course starts, I don't want them to struggle with uh, executing the application. So that's my plan, to have these applications installed well ahead of time and tested, as in like one of the so they should be able to install the application and run like a hello world, run like Selenium, what is it? With the help of Selenium driver, just open one application in Google. So, or not open, or just open the Chrome page. So something like that, and Postman to be installed. That's it. Like, is it
Yeah.
possible? Well,
uh, you will be uploading all those details on the My Academy for them to read it and proceed with the installation, right?
correct, correct. I'll do
Yeah,
that.
yeah. They can they have to start with that, and if they face any issues, they can mail us, and I will be helping them in the installation issues, etc. Yes.
Okay, perfect. Yeah.
Yeah.
So I would follow this strategy, whereas like next week, or maybe by Monday or Tuesday, I would find all the uh videos for self install installation, sorry, and
Yep.
then people can follow.
Yep.
And if they have any problem, they'll reach out to you.
Yeah, and I'll reach out to you, Shrikant, again after the like separately about the coursework, whether you have given them anything to assess for me. All those we will do it offline. Okay.
Sure, 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 sure. We
Thank you.
can.
Thank you. Sorry for disturbing, and I'll be attending the session too. Yeah. Thank you.
Okay, okay. No worries.
Yeah.
Thanks, Anita.
Yeah.
Okay. So coming back to why software testing is necessary. So first thing is like, yeah, the very first and foremost thing is what happens when a requirement is misunderstood and developed based on that. So when it comes to testing, QA will find it, because we will be going through the requirements document properly and making sure whether the requirements and the development is matching or aligning or not. So that's why that's like the very first one. So we just like to verify the requirement that by the software design design and development are in line. Okay. The second one is to, yeah, the second one is to make sure that the application is performing some request at acceptable time. So um, imagine in case of creating a user in Instagram. So after you put in all the information, you select all the information as in name, place, date of birth, and everything. You click on submit. The time it takes to process your request, that should not take forever. Plus, when you open your application, uh, when you see that there are lots of posts which you have made, so those posts should load up in like less number of time. So uh, to make sure that the usability of the application is really nice, and functionalities are working uh, properly with a good response time. It should not be like you click on some button and then you're waiting for like 5 minutes to for the operation to happen. So that is again one of the requirements for, and that is why software testing is necessary. The next one is to make sure that the software is efficiently uh, used, and like it is in stage where it can be easily used. So it should not be very complicated, but again, this is like this would be coming from business side, but however, when it comes to testing, we could also provide a suggestion saying that um, the screens, imagine like there's a screen which has like first name or some ambiguous name given to it. So like first name and last name is written in like two different fields instead of one field. So you can you can provide an input to BA saying that this is causing some ambiguity or like confusion. So BA would again go back and try to review it. So there also you can give some information, and that in turn makes the or like blocks this product to go from testing to production, and or it will block this functionality to go from testing to production. And at the end, we have to make sure that we satisfy the stakeholder desire. So whatever stakeholder wanted from the application, with the help of software testing, we make it sure that, okay, this is what the application which you have told us we are developing, and it is working exactly like how you wanted it to work. So to satisfy the stakeholders desire. Okay. We are done with software testing, the need of software testing, and why is it required. Plus, okay, and then there are some more things which I can say about software testing necessity. One very important aspects of software testing is, imagine that some of the defects or like the issues which were not caught during testing phase, and if it goes into production, then it would cost first is like time and money to fix the issue which was found uh, in the production, because like the testing was not completely done around among that functionality. So the fix could be like very small, as in like it would just take 1 day to fix, 1 day to test and develop and then deliver. But sometimes fix takes like longer. Uh, Imagine like a very big functionality which is not working, like how I took an example of like Scotia Bank not having uh, the payments to be processed. It's like a big break, and to fix that it might take like 1 or 2 days, and then to test that functionality around that to test functionality plus the functionalities around it, it would take another 2 days. So 4 days of testing, which involves like again a lot of money, plus it would cost companies reputation also. So with the help of testing, we are kind of saving the money by ensuring the quality of product, and then we are also ensuring customer satisfaction. And uh, with the help of all these, we are making sure that the software's performance is going to be very good. So I can at this point say that we help in saving money, and we make sure that the quality of the product is better, and achieve customer satisfaction. And overall thing is performance. Performance and quality. Yeah. So any questions on why testing is necessary? Or I can go ahead with a very good topic called SDLC, software cycle. We will be discussing about software development lifecycle. I have given a brief introduction on our morning session, which is uh, again like what happens in software development lifecycle, software development process. Now we will follow this software development lifecycle through methodologies. What is methodology? Methodology is nothing but there are certain way or there's a process which every software company follows, and waterfall is one of the methodology where you would see. Let me open one of the diagrams to show you what waterfall looks like. Okay, so this is waterfall methodology where software development life cycle follows steps, where the first step is requirement analysis. What happens here is like in waterfall methodology. So whatever I've discussed today morning was like different systems, different sections of software development process. And here we will be discussing that how each and every um, step is performed and how we move from one step to another and what is the process behind it. So waterfall by itself, like it's a linear approach. So which means like first requirement has to be gathered and then analyzed and then documented. So what happens in this part is uh, all the stakeholders will meet, they will get the points or the requirements and then give it to BA. BA will go and make the BRD document. And until the BRD document is signed off or reviewed, we will not be moving to process 2. So waterfall is like each and every section, the section before it has to be completed first, and then the process would move to the second part. So imagine that a process of software development started where like requirement analysis is not completed, then we can't move to design stage because first requirement analysis has to be completed, signed off, reviewed, and once it's done, we will move to second stage, which is designing of the software. In second stage, again, software solution architects will uh, will get this BRD, which is like approved from all the stakeholders, and they will design a high level design document which will have all the different, all the high level designs, as in like how UI should look, how database should look, how these guys will interact with each other and things like that. And then they will pass that to their they will get the document first reviewed, signed off, and then pass it along to the development. So again, development would not start until design phase is completed. So design phase has to be completed and then it moves to development. Developers again would take high level design document. They will create some low level design documents or like some functional requirement specification documents with the help of this high level document and BRD, and create what we say design for how each and every small modules can be developed and how are they interrelated. So they will have like use case diagram, they'll have like use case diagram as in like who are the users, how will they interact with each other, how different modules will interact with each other, so the things like that. So once that is completed, the those designs will be passed to developers, where developers will start developing the code, or the coding phase starts in this process. So once unit modules are developed, then they are all integrated with each other, and finally software is, so finally when all the functions which are mentioned in the designs are developed or like coded and unit tested, they can say that, okay, we have completed programming or the application is already developed. Now it can move to testing phase. So development team or the development head will say the development of the entire project is complete and now it can go to the testing phase. So until the development is complete, testing phase does not start. Testing phase will only start once development sends a sign off and gives the project gives the code to testing team. Now what happens in testing team is like, now once they got um the code, they already had the BRD documents and design documents and everything. So now testing team would start executing the test cases and start testing the project or what was developed. And once the testing phase is complete, we will give a sign off. And yeah, and in this phase, like in testing phase, if we identify any defects or bugs, we will send it back to the developments and development team will fix those bugs and give us the new code and we will test that. And finally, once the testing is complete, we will send it for maintenance. Maintenance is nothing but either deploying the code in for user acceptance testing or for production. So this is like a linear approach where, as you can see, that first one has to be completed, then it would move to 2, then 3, then 4, then 5. So here what like there is a, so this is followed, this was followed actually, I would say, from 1990s till or like 1995 till 2013. So early 2013-14 when Agile was not introduced or like other verification validation models were not introduced. So this was like a very basic type of software development lifecycle which was followed, where first, which is like a linear approach. So every section before them had to be completed in order for the other section to start. But again, this came with some drawbacks. The drawbacks were like, if there's a problem in design, then it would not be identified until the testing phase or like until the testing is done or even later on sometimes. If there is issue which is still present even after testing, then it would be identified later in the time. So imagine like if this starts in January and the project is for around like 6 months, testing would take around 1 month at the end. So development took 6 months, testing is 1. So 7 months maintenance, or not maintenance. So after 7 months, when the application goes back to the market, and if there is some issue with the product, then it has to go back to stage 1. So to get that fixed. So we see the time taken for this complete development is too much. And if we've identified that there is some design change or anything like that, then it will impact the cost. So the cost to fix the issue will be like very high because it was designed like later in the phase. So like we've already, for 7 months there was no business, and after 7 months there's a business, but now there is an issue which needs to be fixed, and it again has to go back to the design mode first. So design will be fixed, development will be done, test.
I have a question.
Yes.
You said it earlier that there are always approvals at each stage, but is that just for testing or for this one as well? Because if there's approval given at each stage, I should presume there's approval to given for the SDLC cycle. So like approval, so wouldn't you have gone through like requirement stage would have gone through some kind of approval and maybe in quotes QA, maybe not QA, but I don't know the word to use, but are they not supposed to have been
Sorry,
approved?
Ali, like your voice is a little bit low. So can't really hear you.
Hello, can you hear me now?
Yeah, can you repeat your question again, please?
Yes, I said you were saying like, sometimes like maybe there's issue, the testing people see an issue and everything, and then like you have to go back to maybe the design, and that would you lose money and everything. But I remembered you said at the beginning, I don't know if that's just for the testing, but that there's always approval at each stage. So that is if there's after the requirements, it has been approved by the business analyst, then the design people, there will be some kind of approval at each stage of the project. So like, is that not going to cut the possibility of having issues then at the testing stage? Like if there are approvals already and then approval has gone and they've gone through everything, then can the project still be stalled? I don't know if you understand my question.
Oh yeah, I can understand your question. Yeah, it is definitely possible. So there are cases when like the business want so you can see like business want like very complicated things, and with the development team or with the amount of resources they have, they won't be able to meet all the requirements what the requirement or like all the functionalities. Look, there could be some complex functionalities which would involve like more time and more money. And it would involve like more resources, and sometimes like some projects they don't have like that amount of resources to come up and design the things which was like which was present in requirements document, right? So sometimes it is not like a like it does not happen all the time, but like some cases that happens whether when like development team says like this is very complex scenarios and it won't be able or like they don't have the manpower to finish it at that point. So in those cases what happens is like even though they have the approval, it would be sent back where business requirements has or like the solution architect will say like this is not possible to do at this point. Like imagine they came up with like some requirements which is not possible. I mean at this point it is possible because like most of the application is or like most of the development can be done, but like I'm talking about the earlier phases when all the functionalities like couldn't be developed. So during that time, like we would, or the design team would go back and say to the requirements team, like, okay, this you have got it approved, but this can't be developed. And then requirement again has to be rewritten, and then they again would go back to approval stage or approval phase and get it approved.
Okay, thank you. I
Yeah.
understand.
Correct. Yeah. So this happens like in real time scenario, like all the functionalities or like there not all the functionality, there'll be like one or two functionalities which is like very complex or complicated, and development team won't have either the resources or the time in which the product has to be delivered. So in during those cases, the business is notified that we won't be able to finish it due to the time limit or functionality limit or the resource limit. And then however, this can be adjusted in future cycles. Like, so this is like one cycle which I'm explaining. So after the first cycle, there's always a scope of, advancement into the application. So new functionalities can be added into the application, and how it would be added is again, it would be sent through a charter document, right? Where stakeholders will send like, okay, these are the functionalities which we want in addition to the functionalities in which we have. So very easy example is like, imagine the very basic Instagram application where you would just be able to post the pictures. But nowadays you have like reels, you have uh, like posts and so many like you have like daily statuses or whatever you have. Uh, so so those were like additional features, right? So those would have come up as like the charter document and with the new feature or like the new business requirements, and they would again follow the same waterfall methodology into the next cycle. So if your application is following waterfall methodology, then it would follow these 5 stages and it will keep going on. So it will have like requirements, design, development, testing. The next phase will again start from requirements, design, development, and testing. The only problems with this is if an issue is identified in testing phase, the effort of fixing it is high because we have wasted like we have not identified that during these two phases. And if some issue is found during like the imagine like if this to be a time graph, then if it is found during uh, a deployment or production phase, then it will take more time to fix it. So anyways, any defect which the more later it's found, the it is going to cost even more money to fix it. So if a defect is found like after 1 year of project, uh, then to fix the defect, it might cost a lot of changes into the project and a lot of testing. So it will just, so I think there was also say which says that uh, the more longer uh, or the more longer as in the more the time it takes to identify a defect, the cost increases exponentially. So the cost or the graph would be in this way. So it's exponential increase. I don't want to show the graph right now. So when do we follow this? Let me quickly see. Okay. So what are the pros of waterfall technology? There are some pros which are like clear documentation. So each phase has specific deliverables and documentation is emphasized, provides a clear understanding of project requirements and progress. So in requirements phase, we will have like a clear documentation on what the requirements are, and everything would be signed off and then sent to the next stage. And waterfall methodology is very stable. It's like it's well suited for any projects. And why is well suited? Because it's like it has like well defined requirements and unchaining requirements. So like there is no requirements which will change. Once it's decided, it's decided. Next, it won't change. So those are like the pros. And the third one would be that it's easy to manage, since one team would finish one work, then it would move to the next stage. Next team will finish its work and then next stage. So it's easy to manage this way. Now, yeah, where are my notes? I forgot to mention the notes. Okay. Waterfall. So I can say that it is waterfall is linear because we say that it has to it is like it represents like a waterfall in any place. So it has to go from upper level into the lower level. So it's linear and sequential. So it has to follow the path. And then second one would be like it has 5 phases. First is requirement phase. Second one is system design phase. Third one is implementation phase. Third is integration and testing phase. Fourth is deployment phase. Sixth is maintenance. I have explained all these phases just above, so I'm not going to note down the points or break it down here because it's present in this phase in detail. However, I'll definitely mention some pros of using waterfall, which is first one, I would say that it's clear documentation, because once a document is approved, it will not be changed. Like once a document is approved, people will be, or once a scope is decided, people will start developing on that. So that would be the case. Then it is very stable. ITY, and then easy to manage. Our cons are It's very rigid and inflexible. Inflexible as in like if there's a requirement change, then it has to again follow from stage one, which people will not be happy about, and uh, they don't they wouldn't want to do it. So it would come into the next phase, as in like next cycle of waterfall. So like the first cycle would be completed, then there'll be like if there's any change required, then it will come into the next stage in the next requirement analysis and next design, next development. This phase will be completed. So it's like inflexible in that way. And here it is limited client involvement. So client involvement is only in the first stage, which is like first stage is the requirement gathering, where business people will be meeting the stakeholders, uh, and stakeholders would, or the business people would not be meeting any developers, testers, no one. And after the complete process of SDLC, which is like after it reaches to the maintenance stage, client will be demoed the application. So the first time a client or the person who has requested to develop this application would see the application only when it comes into the maintenance phase, which is like at this phase, if client does not like some of the requirements, again, it's a problem, right? So since the clients are not involved in any of these phase, there are high possibility that, okay, I wanted application to be developed in this way, but it's not doing the thing. Because of some assumptions from BA, some assumptions from developers, some from testers. So like things could go wrong anywhere, and that could cause issues. So this is one of the con that clients will not see the product until it is completely tested and deployed. So that one. And again, it's inflexible, as in like since once the requirements are fixed, it would go to design and then it will go to implementation. And once it's implemented, it will go to testing. So anything which is identified here, which says like, okay, requirements can be made better, it can't be it won't be yeah, where it says like requirement needs to be changed, it won't be possible in that phase. It has to come into the next phase, as in like next cycle of waterfall. So waterfall is also like a cycle, so where you will finish like one phase at one time, and then you have to again start from requirement gathering, which is like addition to the current one, and then again all these things will follow. So it will be moved to the next phase. So that's why it's like rigid and inflexible. And then there's like limited client involvement. So this is like a big con, because what if the client does not like what they are seeing? And then again, one big problem is testing is at the end. So if there is if if the since we do the testing of complete application and not the part of application. So when the complete application comes into picture, there are a lot of things which are broken. This in turn causes like delay in delivering the product. First thing. Second is uh the second is it will cost like a lot of money to fix the problem, because we do testing at the end. If this now you would be like, you would be thinking like, what is the better way, right? So we have other methodologies like Agile or V model, uh, where in Agile, where like the application or the process is split in a way that testing can be done for whatever is developed at that point. So we will cover Agile part in like few minutes, but at this point, I would say that since the testing of entire application done at the end, if there is any defects identified, it would take a lot of time for developers to fix it. So that delays the project and that increases the cost. So testing at end is one of the biggest con. And then it is high risk. High risk as in like, what if the customer requirements are not clearly met? Then this provides like a high risk, and then to fix it again, it will take more time, or like high number of days, because it has to follow the process of waterfall in order to fix it. Also, it said that this methodology is not for uh, it's not for, or it's not suitable for complex project. It works well with design or the project which are not very complicated, for which I would say waterfall methodology can be used by applications which are very simple, or the requirements for which does not change based on the inputs from, or based on the current changes into the environment. So like, imagine making a simple website which is like which just stores information about a person. So things like that can be easily developed with the help of waterfall methodologies. But imagine some things where application needs like a lot of changes, as in like there's always new things coming into the picture. So for those kind of project, uh, it is not efficient to follow waterfall methodologies, because once a requirement is fixed for that phase or for that period of time, requirements can't be changed. It can only be changed into the next phase, which is like after this phase is complete. So next phase, uh, if we make any changes, it would again follow all these 6 steps. So is there any questions on waterfall methodology? Because this is one of the most important methodology, which was followed for like long number of years by software industry, and then a big breakthrough happened where we moved into different methodologies. One of it is V model, which is like extension of waterfall, and the other one is Agile. We will be discussing about V model and Agile now. But before I move into these methodologies, do you have any questions on the waterfall?
No, I don't.
Okay. Are you guys following, or do you want me to slow down or increase, or you want me to uh, explain anything, like some topics in detail? Please do let me know that, okay?
Yeah, yeah, it's fine.
Okay. So we are done with waterfall. Now is V model. Why is it called V model? And why was V model even introduced? So we see this cons. Cons is like, from waterfall methodology, which is like it's inflexible, and then client involvement is very limited. Testing is done at the end, which causes like high risk and is not suitable for complex project. So what this industry people did is like they tried to come up with something where requirements uh, where they could verify the requirements, where they could verify the system design, and where they could verify the implementation, right? They wanted to verify this. All verification was added to all the stages in order to reduce uh, the risk, and I will show you how. So V model, let me bring up the picture. Okay, so can you see the verification model?
Yes.
Okay, perfect. So this is like the verification model where we see concepts of operation. So we have V here in such a way that on the left-hand side, it's all on how, or it's all on the requirements. So first part is requirement is gathered here, concept of operation, they call it in this phase. And on the other hand, it is, so one side of the V, which is on the left side, it follows a waterfall methodology. And the other side, it's again, other on the right side of the V, I would say it follows like a testing. So one side is like validation and the other side is like the verification. So what happens here is like, on the left side, first a business requirement is gathered. On the right side, we are testing the operations, like what are the, or like what is the requirements by itself. I think this model or this diagram is not very efficient. I'll show you a different diagram, which is like way simpler or easy to understand. Where did it go? Verification and validation model. V model. Let me quickly snapshot it. I'll just try to open this V1 model. Okay, yeah, this one is better. So what happens here is like there is verification phase and there is validation phase. So first one is requirement gathering. So what happens in V model is in stage one, requirements are gathered. So here it would follow the same technique of waterfall methodology, but on the left side, we are saying that instead of waiting for the entire code to be delivered to us and then start the testing, what we have done is like for every stage in requirement or SDLC model, we are trying to have testing or testing side as well. So once the requirements are gathered, we will try to go over the requirement documents and create some user acceptance testing. So user acceptance testing, as in like we will start writing like test plan, test strategy, test cases for business level. Then requirements is gathered here. Requirements moves into the next stage, which is like analysis, which is like again high level design. High level design. Document is created by architects and they will give that document to testing team, where here we would try to make some system test cases, right? Some system test cases to make sure that all the system test cases are covered and it's present into the system. The third stage would be for software design. So when software design is being done in the testing team, we would start creating like integration testing, as in like how two systems are going to interact with each other, or like how two modules are going to interact with each other. Then in development phase, there'll be a module design, and here we would write unit testing, or they would start their coding here. So once the coding is developed, we would already have verified or like the test cases which we are going to execute once the code is once the code is delivered. So as soon as the code is delivered, we will start our testing, and this in turn increases or like reduces the risk of errors being identified at the later stage, right? Because if there is any problem with some functionalities which we have verified during requirement gathering, we would tell it and we would identify it beforehand. So That in turn reduces the risk by a little bit. Does not reduce the risk by a lot, but does reduce the risk because these requirements were first verified. So that's why here it says verification phase, where you're verifying the software without executing the test cases. So you're just going through the documents, seeing that, okay, this could be a potential issue, this could be a potential defect, this could be, or this functionality does not look to be right, something like that. So that is done during verification phase. And verification phase is done for all the 4 parts. So when you get the BRD document, when you get like a functional specification document, and when I say you, I mean like the testing team. So when testing team gets like requirement document, they do a verification that time by just going through the document, by just going through the functional specification. And how do they identify? Like, because they would be creating the test cases for those things which they have received. So they would be, when we get requirement document, we would be trying to figure out what is the end goal, or what is the end yeah, so for requirements we will try to understand what is the end goal of the requirement and see and have it noted down, and if there is an issue we would flag it that time. Then when we get into system analysis, we will see what are the different systems and how as a system, um, how as a system uh, we will be testing it. Like our like system testing is again like end-to-end testing. So like from for if we take Instagram as example, then from creating a user till posting comments and like everything. So like everything is involved together. So that is like system testing, where you test each and every module of the system. So you will have the functional system or functional specification document where you would test it before, or you would create like test cases before even you have the application. So that way you will identify some issues earlier and you will let the concerned team know and they will fix it. So that way what we are doing here is we are trying to identify potential issues and we tell them, or like the respective team. So we tell business analyst like, okay, this looks like a potential issue. Some in system analysts, we tell like a solution architect like, okay, this could be a potential issue. And we also prepare ourselves with the test cases of what we will be executing during these phases. So this is what happens in verification phase, and this is what happens in. So once the coding is complete, we have the code. It would go through unit testing by developer. Integration testing will again be mostly be done by developers. And when it comes to system testing and acceptance testing, we come into picture. We do system testing and acceptance testing. In very rare cases, we also do integration testing, but that is like very minimal. Not all the teams would let like QA do the integration testing, but if there is like if there are two systems which are interacting with each other, we will do that testing. So that would again come as like end-to-end system testing. But if it is just two modules interacting with each other, this would be done by developers. So both unit testing and integration testing would be done by developers. Testers will do system testing, acceptance testing, and in few cases, very few cases, just QA person will be allowed to do integration testing. So this is about V model. And let me quickly show one more of what has happened. So I have one more picture, which is like very close to the picture which I'm showing, but it has like a even more detailed view. So let me open that one. Let me know if you can see the screen. You can see the snipping tool right
We
now,
can
right?
see the screen here.
Okay, perfect. So whatever I was explaining right now, it's present in a what we say graphical representation. So we see this is the requirement analysis stage. We prepare like acceptance test cases, which is here. And then during system design phase, we create system test cases and do the system testing. But again, the testing will be done only after the code is developed. But however, at this point, we just say that we go through the requirement and the document, and then we do a verification. Verification is not by executing anything. So you're not executing, you're just going through the document, you're reading the document and trying to find the issue. And then again, system design document, you'll read the document, identify the issue, let them know. And at the same time, you will start writing the system test cases, which you will use during system testing. Similarly, for architectural design, you will start writing integration test cases and you'll do the integration testing. And these three are for developers mostly: module design, coding, and unit testing. We don't generally do unit testing, so it would be done by developer. So is it clear on like the V model, what it is, what is verification side, what is validation side, different stages in V model, and on verification side and validation side as well.
Yes, it is, at least on my side.
Okay, that's nice. How about Adi and Salim? You
Well,
guys,
yes, it's okay. I think when we start to use them or see how it's used, because there's a lot of terminologies, but I'm sure when we start the real, to start to use them, maybe it'll be more like it. But I understand at least from the diagram.
yeah, at least at this point, my say would be that I want you guys to understand, what the process is. Forget about like what we would be doing inside, like in detail, but I want you to be like, if someone asks you a question like, okay, what would happen in a software development life cycle? So at this point, I want you guys to be at least answer this question saying that, okay, there are like 4 stages. I know that first there is a business team who creates like business requirement documents. Second is like solution architect team who will do a system design. Um, Third is like architectural design team, or like the implementation team who would do a low level design plus start coding. So things like that. And then it would move to the testing phase where testing team would write like test cases. So I want you to be clear about these different steps in software development lifecycle and what happens in each stage. So I want to be clear there. And if I'm clear there, and if I can if I'm conveying that thing properly, then my task is good.
Okay.
Okay, so this was like the V model. Now we'll discuss some of the pros and some of the cons of V model. And again, stands for verification and validation. Some people call it like V model. So it's like verification and validation. In lots of interviews, they will ask you questions on what is the meaning of verification and what is the meaning of validations. So as I said, uh, for verification, you go through the documents and try to identify the issue. But in validation, you really go and execute the test cases, or run through the application and do the testing manually or by automation and find the defects and get it fixed. So that happens in validation. So coming to the pros, as we know, it is very simple to use. It's very easy to understand, and it follows a systematic and very sequential approach as well. So it has like a sequence which it follows. It comes down from here, and it comes down like a waterfall, and here it goes back. So which is like reverse waterfall, I would say. And since we have like each phase here has a delivery uh, associated to it, so we are not losing what we say in waterfall methodology. We had like a pro of the requirements are documented properly. So the pro is still present, because at the end of each each stage, we still have the document. So that process still continues to be there. And here, since we are going through the requirements document earlier, we are trying to identify the defects or like the issues in early stage. So that is one of the defects. And here we can also see that the stages are very well defined, because at each stage we know what is expected from the previous stage and what is expected from each stages. So that is well defined. However, cons are still that it is rigid, as in like there are still chances of identifying defects beyond this point. And if there is a change, so imagine that there is something which is identified even after this. So there could be potential issues which is identified here. If this is a time graph, like if project started here and testing completed here, and this is time zone, then the defects which is identified at this time, what would happen with them? So they, for for those defect, it has to again follow the entire phase or the next cycle, which is which tells that the system is a little bit rigid. It's not very flexible still. And you would know that the system could be flexible when I'll be telling more about like Agile, what happens in Agile, and that will change like the ideology of, okay, this is what we wanted, and this would fix most of our problem. And again here, the con of customer will not see the product until this point, until we reach to the time where complete testing is done. Developers will not see the, or no, sorry, not the developers, stakeholders will not see the product itself. So that still remains a con. And again, this project is again this methodology is again not suited for complex project. And this this methodology is a little bit time consuming, because we have to, yeah, this is a little bit time consuming, as in like it is exactly similar to what waterfall methodology is. So they sometimes call V model as like the extension of waterfall methodology, where like you're just adding these 5 steps into SDLC process, where like you're verifying something. So risk is little bit less, but rest of the cons still remains in the project. Okay, so now I will list down in the notes also for us to keep it with us. Where is notes? Okay, V model. They call it verification and validation model in SDLC process. The very first thing we should know is it is extension of waterfall model, and we can say that with the emphasis of, or with emphasis on validation and verification activities at each stage of SDLC. So the name is derived from the shape model. And different stages are requirements analysis on one side, then system design on one side, then architectural design, module design, implementation, or I can call it coding, and the final is integration testing. So instead of writing this here, I can also Control X. I can say this as part of, on the other side of this. Here it would come system testing, and here it would be acceptance testing. Okay. So I would not write anything for these points because it's already written in the section here, but I will go ahead and write some things on all these, on what each steps is. So unit testing is testing each unit of the program done by developer team. Integration, so it is nothing but combining individual modules and testing the integration. So this is what we do in integration testing, system testing. So I'm just writing down whatever I've explained in the diagram. So it's not anything different, but I'm writing it down so that we could use it while revising or studying again. And in this phase, we would also identify and fix any issues with the module interfaces. Yeah, because when we are trying to when we start testing the integration between two modules, there would be some defects, and we will try to get it fixed by assigning it to developers. And I have not yet explained defect lifecycle. That would be at part of next week's session. And defect lifecycle is like a big part of testing. And in system testing, it is nothing but end-to-end testing done by QA team or QA tester, anything we could say. Here, when I say end-to-end testing, I mean complete system testing done by QA team and it is done to verify that whole system is working as per the requirements. And final is acceptance testing. Acceptance testing is nothing but it's very easy to ensure that the final product meets the customer's expectations. Okay, coming back to pros. It is simple to use. As I said, that V model is very easy to understand and it follows a systematic and sequential approach. And second is a very important pro is each section has specific which means like each section has its corresponding testing activity. I've mentioned this with the diagram, and then here early detection early detection of defect is possible since we are testing each section, right? So I'm not going to explain the more details here. And we can say well-defined phases because this pro is coming from waterfall. Our cons, it's rigid because once requirement is approved, you can't go and change the requirements. So it is similar to waterfall. Then late customer feedback is still one of the most one of the biggest con which V model has, like customer feedback, like customer won't see the application until the end. Sorry. And some would be not suitable for complex project. And finally, it's time consuming. I would say here limited flexibility because to respond, what can we say? Respond to changes in the project requirements. Not suitable for complex project and time consuming because testing is still done sequentially, which is like once entire application only after complete application is delivered to QA. Okay, I think I have noted down everything. So are we clear about the V model right now?
Yes.
Okay, perfect. Now next is Agile methodology. This is one of very important methodology. So I would give you some time before we move into this. So let's take like I think it's lunchtime already, right? Do you guys want to take lunch break right now? Or we should take a small break, finish this methodology and then take the lunch break. I'm open to suggestion. Anything is fine.
I think after Agile, guys, what do you think?
Yeah,
Okay.
I agree.
After Agile?
Yes.
Yeah, just so we
Yeah.
can wrap up the methodologies.
Yes.
Okay, let's do that. So I'll take at least like 5 minutes break and then we can meet again, okay?
Okay.
Yeah. And also like till then you can go through these requirements of or like this methodologies, waterfall and V model before we move into Agile. I'll be back in like 5 minutes. Resume. So now is Agile methodology. So I don't think so. We have any picture on Agile methodology. We have Agile SDLC. Okay. Okay. So what happens in Agile? Let me go through the notes. Okay. So in Agile, what we do is we divide our requirements into small so requirements are first. So here also requirement gathering happens, but all the requirements are listed into a thing called backlog. But I won't say about all these backlogs right now. So let me just give you an overview of what happens in Agile methodology. So here, like waterfall methodology, with waterfall methodology, the project would go on for like 1 month, 2 months, 3 months, 4 months. Like it would be like a long process, right? Because there are so many stages and each stage has to be completed before the next one starts. But in Agile methodology, what happened is like they tried to cut short this long process into small processes. So what they did is like the requirement itself was broken down into small parts. So like first imagine like an application which, so let me give you an example with an application here. So imagine an application which has like login. So again, Instagram as AGRM, Instagram as the application. So it has like functionalities like login, user profile, then pictures, comments, messages, calling, reels, etc. So imagine like we have an application which has like so many functionalities, right? 1, 2, 3, 4, 5, 6, 7, around like 8 functionalities. What we used to do in waterfall methodologies, we would write all this into business requirements document and then get the approval. Then developers will develop this complete application. Then tester will go and test the complete application. So, and at the end, stakeholders used to see, will see working project. So if the project in waterfall was for 3 months long, so at the end of 3 months, stakeholders will be seeing the project because they're because that's how the methodology is designed. So at this point, what if stakeholders don't like the view of the system or does not like how the system behaves or the functionalities, the way it looks and everything? So that will again cause like a lot of impact to the project and its delivery, and it will cost like a lot of money. So that was like a biggest drawbacks or cons for both V model and waterfall model. So what we did is, what not we, like what these IT industry did is like they came up with agile methodology. What happens here? So requirements will still say the same, requirements document will still remain, but now this process of developing, testing, and delivering in 6 months has been cut down to 2 to 4 weeks. So what happens in this 2 to 4 weeks is like first, some requirements is considered. So imagine in the first week. So what they did is like the entire process has been divided into small iterations. Entire product development is divided into small called sprints. So what happens in Agile is, imagine that we are dividing this functionalities into sprints. So we will say, okay, take first 2 weeks, or like if we have our sprint time to be 3 weeks, so 3 weeks, we will develop these 2 pages, these two functionality. Before messing this up, let me do a copy over of these things because so that we can go and restore it back, right? Okay. So we will say we'll give 3 weeks sprint sprint 1. Then we'll give 3 weeks sprint 2. 3 weeks sprint 3. Sprint 4. So what happened here is like the business requirement document would still state all the functionalities of the application, but now what the team would do is it would just pick up two functionalities. So for given example, it will take login and user profile creation functionality, and it will develop these two functionalities in week 1 or in sprint 1. So sprint 1 is divided into 3 weeks where like here we just have one team. So agile stuff before I say okay, so things are application is divided into 3 sprints. So here I would say team and agile team would have like developers, testers, business, Scrum, or like I can say Scrum Master. Okay, so what happens is like so application so the entire process is split into sprints, and each sprint is like around 2 to 4 weeks. It should not be more than 4 weeks. And at the end of each sprint, a working product is delivered and available for stakeholders. So, okay. Now I think I have mentioned everything just to understand this. Okay. So what happened is there was a BRD document which had all the application requirements and everything. Now in Agile, we split this process into various sprints. Of each, so sprints could not last more than 4 weeks. It should be between 2 to 4 weeks. So the requirements which we have chosen for sprint 1, so maybe like login and user profile creation, that has to be developed and tested in these 3 weeks. And at the end of 3 weeks, there will be an application which stakeholders can see, and they can see like, okay, so my Instagram login page looks like this. User can log in and user can create their own profile. So this is what happens at the end of the 3rd week. So what happens here is like, imagine that stakeholder does not like how the login page looks like. So what they can do is they can give us the comments or feedback saying in the login page we want an extra captcha, or we want to add some more logos or some more information, or want to add some ads, things like that. So when stakeholders give those information, we can put them into our requirements and take it as a requirement and try to fix it in the next sprint or into the later sprint. So what we do here is uh, so what all we did here is like we are flexible for the change, uh, or like we even appreciate for stakeholders to say that okay, if the product is not matching your design or desire, we will make the changes, no problem. And here in agile environment or agile methodology, we don't try to document everything. We try to keep the documentation as minimal as possible, and in such a way that it meets the requirements of having the document in place. But we don't do a lot of emphasis on the requirements, getting the approvals, getting through different stages. So we won't follow that it's not very tightly scheduled, or it's not very tight that everyone has to be following that. Just having the document is good enough. But however, we give emphasis on communication in agile team. So communication as in like developers, tester, BA, Scrum Master, they all have to be communicating with each other if there is any problem. And we'll discuss more about like there are different processes in agile. So we will discuss that after lunch. But for time being, so there's agile team, and team is linked very closely. So here we don't rely on documents, we rely mostly on communication. We want developer, tester, and BAs to interact with each other and discuss on the project. So, or like if there's any problem, just discuss it and try to get a resolution. And in agile, we accept the change from stakeholders. We appreciate the change also, and take it into consideration and develop it in later on sprints. And biggest pro is stakeholders would know the application look and feel after every sprint. So this is Agile. So sprints have been divided, and then at the end of, so imagine like sprint 2 is done. So now after sprint 2, we would have like login feature, user profile, pictures, and comments. So like 4 functionalities developed, developed, tested, and delivered. So clients will know all these 4 functionalities are working fine. So what it does is it also increases the time to market, because stakeholders have the application which they can demo to the users, or the actual users, or they can release it to the market, while the other functionalities are becoming like an add-on feature. So which is like a feature to be added in future. So this is Agile, and Agile has like different strategy, as in like now the team members size should not be more than 9. So if there is team member more than 9, then um, Agile team is split into 2 teams and things like that. So I think, yeah, this is Agile methodology, where this is the process. I will be explaining more about how do we follow Agile practices, what are different principles of Agile, what are different topics inside Agile. So that would be like after lunch. That was like session 2 part. And yeah, so for this session, I hope now you understood like what is waterfall methodology, what is V model, what is Agile methodology, and why is Agile methodology better than waterfall and V model.
Yes,
Okay,
it's from
perfect.
my end. Yeah.
That's fine. And we will be diving more into Agile like after lunch, because Agile has like different versions of itself. So one is like Scrum, which is very widely used. One is like Scrum, then one is Kanban, then one is Extreme Programming. Yeah. So we'll be discussing more about these different types of Agile. Plus, we will be discussing what is Agile manifesto, plus Agile principles. So for Agile manifesto, where is the manifestation? In programming. I think it's here. Part 2. Yeah, I think this is part 2, so I'll explain after the launch. Okay, so now we've learned about 3 different methodology. Why is testing required? What is software testing? And now we will see some points on the mind of software tester. Let me just keep this. So how should we, so when, like once you get job and you start testing an application, what are the different, what or how you should be thinking, or like what you would be performing, or how you would be testing an application. So once you get a BRD document, what you would do? Like imagine like you got a document, you say that document says all the functionalities, the scope, and the requirement of the project. Plus on the other hand, you would also have the product in front of you. So now you are executing the test cases which either you have written or some of the other team members have written, but you're just following it to execute. So now while testing, what has to go through your mind? So when it comes to me, the first thing I have in my mind is I want to break the system. Break the system as in like try to do try to test the first is like system should be working uh, as per the requirement. So like at least with my experience, I can say that application would do what is written in the requirement. So the good flow or the happy path scenario will always work. 100% of the time would work. Only there are like, or I would say 90% of the time it would work. 10% it would not work. But the issue would only be on the negative scenarios, the scenarios which user can enter or can go into without any issues, and those will break, and that would also cause like system failure. So the first aspects of my testing is like make sure that everything in the requirement document is working, or like all those functionalities are working fine. Second is to break the system by carrying out various functionalities, or like uh, yeah, by carrying out like various functionalities in order to break the system. So do some negative testing, like try to input values which a field will not take, or try to do a process which is not designed, and make sure that the system also does not allow you to either insert those values or follow those processes. So it's like by logging into Instagram, I should not be able to post pictures into uh, some others account. So I should not be able to, post picture from Addy's account, right? By logging into my account. So those kind of scenarios I have to test. So my mindset should be that this application has bug, and I have to find the bug and I have to get it fixed. Plus, it should not just be to break the system. You should always look for things like uh, response of the system. So response of the system would also be a critical part of testing, where uh, while testing, you make sure that um, when you try to input some data, try to process a request, or try to process anything into the application, the processing time is not too much. And like every product or project has like a response time on like how quick the system should be responding. So we have to make sure that application meets even those. Plus, if there is a defect, or if you find that the system is not behaving the way it should behave, then you have to log a defect, and or like log a bug and send it to developer and ask them to fix. There would be a possibility that developer would say, "Oh, this is not a defect. This is how the system is supposed to work." Then in those scenarios, you have to go to business analyst and then ask them like, uh, this is what is written in the business requirement, or the project is, or the application's functionality is not performing the same way what is written in business requirement. Can you please let us know uh, if this is how it has to be working, or uh, take inputs from business analyst and then send it back to developer if that's a defect, or close the defect based on the conversation with the business analyst. So yeah, so these are the like important aspects of software testers, or like how they should be testing. But now let's go through the points. First one is like logical thinker. Yes, obviously once you start testing an application, you have to make sure that logically, or like the logic behind any screen is working fine. Like logic as in like imagine date of birth field, right? Date of birth field is kind of accepting of a date which is in future. So that is like invalid, right? That is not logical. So if a date field has ability to accept future date, or date as in like date of birth field has the ability to accept the future date, that is like incorrect. Date of birth, if it is mentioned for any application, it has to be like past date, so that is logical. So like if you can select a future date, that is like incorrect. So that is one of the example of logical incorrect. You have to think in a way that this is logically correct or not. So if it is logically not correct, the system should not be allowing it to happen. So that is one. Clear objectives is like make sure that we as a tester understand the requirements and the objectives very clearly, and even implement in while testing it. So like uh, objectives which are written in the requirements document is inter is like understood properly. Make sure like while executing the test cases, those objectives are met. So that is like first and foremost thing which we have to keep it in our mind, and we have to make sure that we follow this entirely like while testing. And the next is emotional intelligence, uh, which is to make sure that if you are in a team, imagine like you are in a team where developers and testers and BA are all working, right? And if you uh, if you try to uh, be in be in line with development team, where like whatever developer has developed, if you say like okay, developers cannot be wrong, and developers are developing a good product, and don't let your emotions come into the play. Like make sure that you always think that developers have not developed the code properly, and they always have a mindset that they are humans, and be they can make mistakes while developing an application, and you should not be emotionally you know drifted or dragged towards the development team, like that they will be doing things properly. However, be like an own team, be like an own individual person, and try to test the application and break it as much as possible. Always, yeah, software testers should always have a very good communication skill, as in like while logging any defects or while sending any emails for any clarifications. Good communication skills like is a very important aspect, where you have to explain the problem um, while either logging a defect. So while logging a defect, you have to say the steps like how to reproduce the defect, and how did you identify the defect, and what are you expecting the system to respond or behave like, and things like that. So you have to be very good with your communication skills. And then again, the next point is detective. Yes, obviously, detective is one of the things I would say, because you are trying to break the system by testing each and every functionalities in various ways. So if developers say a plus b is 2, then you have to try with like a plus b is 5, a plus b is 10. Make sure that all the different combinations are tested, and the product is with good quality. And yeah, like how I said, emotional intelligence and independent testing are like always consider yourself as like an independent team, and you would be responsible for the product's quality. And yeah, you have to be organized as a software tester. Organized in the sense like uh, make sure that you follow all the all the above, which is like while creating the test cases, make sure that you're reading all the documents properly, you're storing all the results properly, you're kind of logging all the defects, following up on the defects, following the project very closely. So you have to be organized in order to do those things. So this is all about like tester's mindset or strategy which they have to follow. Any questions on the mindset of software tester?
That's all for my end.
Okay,
Not
thanks for
at
that.
all.
Okay, and I think the last topic before lunch would be principles of software testing. Let me get this here. I have kind of explained some of the concepts of principles in my session, which I was taking from morning today, but however, I'll go over them again. So what is principle testing? So principle of software testing. The first point is like testing always shows us that the defect is present into this or like defects are present in the system, and we have to make a strategy and try to find all the defects. Plus we have to also see like what are the places which are, while testing a product or like a project, when you're testing, you would come across some of the functionalities which are like completely mess, like which don't work at all. So during those cases, you would find lots and lots of bugs in like one function. So let me take an example of one of the banking example I can give here is like, imagine an app, banking account where you can process, where you can, uh, yeah, so in the banking application, you go to your account and you see transactions from various types. So you can get like transactions like cash transaction, you can get like money deposited in your bank from checks, from payrolls, from dividends, and like many people who would be sending you from different businesses, things like that. So your if the accounts uh, deposit uh, functionality is not working fine, so any functionality or like, so given the functionalities of deposits would be like, there will be different code or different functionalities, as in like how a check is deposited into your account would follow a different strategy or different application part. How a cash deposit is done into your account, that would follow a different set of procedures or steps. How a dividend is provided into your account, that follows a different step. So there are different steps. If deposit screen is showing an issue, then it could be because of either check deposit, it could be because of cash deposit or dividend deposit, or even any interact deposit. So if there's a defect found or if there's a bug found in the first application or like the deposit application, it could be from any of these, and or it could be from all of this. So if it is from all of these sections, that is called like defect clustering in the deposit section. So when one functionality is not working because of and producing too many defects, so that makes like that functionality to have lots of defects. That is called like defect clustering. So we have to make sure to find the areas which could cause a lot of defects. So and identify those areas and test them thoroughly. So that would be like to ensure the test, to ensure that testing is done and there could be a defect present in this area. Plus also, testing is a very big scope. Imagine one application having like 10 or 15 fields, right? And 10 or 15 fields, and testing each and every field with like n number of inputs would be like impossible. So for example, for exhausting testing, let's consider one field which input 2-digit number, right? Field's input is 2-digit number to test. So how many number of tests can we have? So it can be from 0, 1 till 99. So testing an application by manually entering 0, 1, then enter 0, 2, then enter 0, 3, then enter up to 99 will be like very exhaustive. And it is also not possible, humanly possible to test all the 99 combination. It will require like a lot of time. So we have to come up with a strategy, or there are different strategies which we have to follow to make sure that the testing is efficient and we are not repeating the same kind of or similar kind of testing for more number of inputs. So for just this field, I would give you an example is like the function or the code which would be written behind it would be to allow any number between 0, 1 to 99, right? So if you try to enter 0, 0, the system will not accept this input. If you try to enter 1, 0, 0, system will not accept this input. However, if you enter 0, 1 or 99, system will accept these inputs, right? Because it is in between 0, 0 to 1 to 99. So between 0 or 99, right? So it will accept this input. So if you test 0, 5, and if this is accepted as well, you don't have to go ahead and test all the 99 numbers. Like I think 2 numbers would be good enough to test the entire field. You don't have to put all the 99 combination. So this is how you go. This is how you stop yourself from doing exhaustive testing and try to do an efficient amount of testing that the functionality is completely tested and there is no possibility of it breaking even in future. And then we have early testing. Early testing is always good because the earlier you identify the defect, the less time earlier the defect is identified, the less time and money and cost is required to fix the defect. And so if you find the bugs early, it will take very less time and cost to fix the defect plus, and it will kind of decrease the bugs finding in future, like if it is found early. Then defect clustering, I've explained it earlier. Defect clustering is nothing but density of modules to focus the testing effort. So testing defect clustering is nothing but finding the areas where there could be a lot of defect and identify them. Okay. Pesticide paradox. Okay, this is very interesting because imagine there's an application and you have written some specific test cases, and after every time that application is deployed into production, so let me give a better example here. Like imagine an application with let's take an Instagram as an example again. So you open an account, not open, you log in into an account, you post the pictures, and posting picture is successful, right? And developers get a new functionality where now instead of posting single picture, you can post like multiple pictures together. So this is like a new requirement which is added to the system. So there's something called regression testing, which means like you will be testing the current new functionality, plus you would also test the old functionality is not broken. So that happens. So what happens in pesticide paradox is like over and over like time, if you execute the same test, right? So developers would have fixed the functionality of adding multiple pictures, but there is possibility that there could be some bugs introduced for the existing single picture upload. So, and since you're testing the application
Sorry,
with
I don't
same,
really understand the explanation. Please, can you go over the specific paradox again? If you don't
sorry,
mind. Please, can you go over the explanation again? The pesticide paradox.
uh, you want a different explanation for pesticide paradox?
No, as in to explain it again.
Sorry?
As in to explain it again. I don't know why I can't hear me. I can like to explain it again.
Yeah,
I
he's
don't know.
asking if you can explain it again.
Oh, yeah. I have,
Right,
I will.
Thank you.
I have,
Thank you.
yeah, I have not completed it. I was trying to figure out one example to explain this better, but yeah, I could not come up with one because of the multiple feature. Then my head took me to some different side. Okay. Anyways, let's make it very simple. I don't want to complicate this thing. Pesticide paradox is nothing but uh, testing an application with. So imagine like first time when an application is developed, you tested the application with some test cases, uh, and identified a lot of bugs. Right? It went to developers. Developer fixed all the bugs, and you tested the same test cases again. And while testing the same test cases, uh, you figured out that all the bugs which you have identified before are fixed. And now you say, okay, the testing is complete, application is working as expected. You finish uh, the testing and application is sent for production. Now, when the new release happens, or like when during the next phase of testing, uh, if a functionality is added, which is around this functionality, then same number of same if you keep running the same test cases again and again, there could be defects lying and it would not be identified because developers have identified that okay, testers has written this test where every time we make this mistake, they find that mistake. So now when they are coding, they are very careful and they're very vigilant. Okay, we should not make these mistakes again because they have the code for it or like the test for it and they catch us. So they will fix those. But like since we are not changing our test or like we are not updating our test, there could be other defects or like other issues which developers could introduce in the same functionalities for like by some other ways, and that will be uncaught. So pesticide paradox is like developers getting very used to the same test cases which you are testing, so they are fixing those kind of test cases, but there are but there are other bugs which are going uncaught. So how do we overcome pesticide paradox? It's like making sure that we keep updating our test cases. We keep updating our test cases as in like we are keep trying to come up with like different scenarios to test the functionality and then test it. So that way, developers would have fixed all the our existing test cases or like our existing functionality or existing testings which we had. Plus, we'll have more other scenarios discovered to catch the uncovered bugs. So, is it clear now? The pesticide paradox?
Yes,
Okay, perfect.
absolutely. Thank you.
Okay, no worries. So, pesticide paradox is nothing but new test should be developed to exercise new parts of the software. Okay. Yeah, and testing is context dependent again. So imagine a date field has to be in date format. It will take all date related stuff. Then alphanumeric text field will take input as like both alphabets and numerics. And then just numeric field like phone numbers would take only numeric integer. So here we say that you have to be sure that when you're trying to test an application or test a field or anything, you have to make sure that the context for testing one application will not be similar to testing other applications. So while testing online web-based application, you have to make sure that the URL is always present. URL is pointing to the correct location or not. But however, if you're doing desktop application testing, you don't have to worry about the URL, right? So because desktop application does not have to show you any URLs, it will be present in the application somewhere. So things like that. So like different application has to be tested in a different way, and it has its own way to test it. So we have to make sure that the test cases which we write for like desktop application will not completely be same for a browser based application. So that is one of the principle. And the last one is absence of error policy. If a system does not fulfill the user need and expectation, then having a bug-free system does not help. Yeah, so the final one is that imagine we developed an application which does not fulfill the need of the users or the the users don't even want to use it. So the use in that case, our application is of no use, and we have to be sure that whatever we are going to test or develop is user friendly, plus it's beneficial for the users, and users will like to use this application. So like developing something which will never be used is as useless as not developing anything, right? So this is that. So if so here I would say it's a system which does not fulfill the user needs and expectations, then having a bug-free system does not work. And here is like different kind of system is tested in a different way. Okay, I think I have covered all the topics successfully for part 1. We did go over through what is software testing, some history, why software testing necessary. We went through all the SDLC models, then a mind of software tester, principles of software testing, and I think that's it. So do you have any questions on any of these topics which we have discussed up until now?
On my side, no, not yet.
On
Okay,
my side, so no,
okay,
no, not yet.
okay.
Same
Just,
here.
I think
My
at this
side.
point we can take some break of like 30 minutes, and then we can come back by, what is the time? 2. We can meet again at like 2:20 or like, yeah, 2:20 again, and we'll go over to the next topics for today. Okay, so see you all by like 2:25. Rather, I'll give you some extra time here because it's first day. Let's take it slow. So see you at 2:25 p.m. Yes. Pause the recording. Resume. Okay, so now we'll move on to section 2 of today's session, where we'll be first going through what is Agile and different. So, what is Agile manifesto and principle, and different types of Agile programs, which is like Scrum, Extreme Programming, Kanban, and then some Agile uh, what we say ceremonies which we do, plus some agile terminologies which are most popularly used uh, in almost all the software test or software development lifecycle. Following which we will see some test design techniques, uh, mostly like black box, white box, uh, and some black box testing strategies like equivalence partitioning, boundary value analysis, decision table, state transition. Following which we'll see some use cases, what are different types of use cases, and some static analysis, like how do we do static analysis. And I think that would be the wrap of today. So without any delay, let's start. And so before going into too much into detail, I would like to understand, what do you feel? What is Agile? Anyone can answer. What is Agile? Uh, Based on my morning session, you can be wrong or you can give incomplete information. Doesn't matter. But like, what do you feel like? What is Agile? And why do we choose Agile? Like, based on my session.
Well, Agile is the division of projects into smaller sprints,
Yeah.
for the ease of testing, and as well as being able to detect defects easily. And then we choose Agile because, of course, it is all inclusive. All the stakeholders can make changes from time to time.
Mhm.
And then, of course, even for software, at least from the things I've read in the past, it's always used for software projects and all. So, yeah.
That's perfectly, and that's what. So Agile, that's completely nice. Uh, and very good answer. So now, as you said, the Agile, we break the process into multiple parts, and then we have uh, we have like a working software. The working software is like the main point, where it's like we deliver a working software after each sprint or each iteration at the end, right? So that is like the most important part. And all software development and testing happens in like just 3 weeks of time, or like 2 weeks, or like 4 weeks, but not beyond that. So those are like very important and interesting points. So now going back to, let's take this, put it into a notepad, and then we'll start this. Okay. So first thing is, Agile has some values. Okay. And they have around 4 values. The first is, the values is individual and interaction, and interaction over process and rules. Okay, so what this means is like, Agile kinds of appreciates that individual should be interacting. So like team members should be interacting with each other, okay, rather than rather than following process or rules. So like uh, a tester can interact with developer and business analyst. They don't have to follow any kind of a rule. They can directly go and talk. They want people to talk, meet more, and this process of me telling it to my lead going and talking to business lead, and then the process. So a testing team, take an example as testing team. So just the team member would inform all the issues to um, test lead first. The test lead will go to the business analyst. Business analyst will then resolve the issue. So this process has to is kind of eliminated by giving every individual the power to interact with everyone, and it is also appreciated. Like, instead of going through or following through a chain, you directly go and interact with the person and save time. The second one is working software over comprehensive document. So our focus would always be on working software. We are not going to focus more on creating lots and lots of documents, be it like BRD, BTSRD, FSD. We are not focusing so much on those. We are just trying to make sure that at the end, we will deliver a working software, because that is the only which matters. But however, it does not mean that we eliminate the documentation. Documentation is still there, but it can be minimal. And then customer collaboration over contract negotiation. So in waterfall or V model, there's always contract negotiation, which is like at the end of the in waterfall methodology, at the end, if there is something which is not aligning with the specification, and if customer wants something new, right, or something different than what it is designed, so what will happen is there would be negotiation which will go through. So uh, like there's something called service level agreement, and that would involve like some, again, kind of money exchange. So imagine like clients paid you to make an application, you delivered it to them, and for even small changes which they are expecting the application to have, they have to go through again the entire process of business or like software development life cycle. Plus they have to give extra money, obviously, because it involves a lot of resources and a lot of things. So here we are trying to eliminate that, because we are giving clients or customers upper hand, saying that if you don't like something, tell us now, because we don't want to go beyond 3 months and then you say that, okay, I don't, I would have, told you guys 3 months before that I wanted this feature to be working like this way. So that's why we here in Agile, we want customer collaboration rather than negotiation. So customer should be happy about the product and the project rather than thinking about how much it's going to cost and so. And the final is responding to change. To change over following a plan. So what this means is like we would, if while development or while demo, if there is a change which is required, we would uh, we would take those changes and we would put it into the plan, and we would work our we would change our plan of development. Imagine like there are 3 functionalities, and one of them is wants some change, and that is impacting like 5 days of extra work. So if it was SDL, if it was waterfall or agile or like different methodology, those changes would happen like after 3 months. But here we will change the plan. We can change the plan. We will make that, okay, instead of delivering this project in 1 week, we will deliver it in like 1.5 weeks, and we will try to incorporate these changes into the next sprint or something like that. So we respond to the change and over following a plan. We are flexible with the plan, and we want to make the changes of whatever clients want. So we, at the end, Agile means like we will be giving client a software, a product, and clients would see the application as like all the flexibility to make any changes to the application, and we all appreciate the change. And on the other hand, we also say that, okay, we won't do a lot of documentation, only enough amount of documentation is good, and there has to be a lot of interaction between the teams so everyone can communicate with everyone. So that's the way. So I hope Agile values are clear. And this is very important because this is one of the most important aspects of Agile. The next is Agile principle. Agile principle or manifesto, they call it. Manifesto. Okay, so there are 12 principles. I have it written somewhere, so I'm not planning to rewrite it, which is very time consuming. So I'll just explain those principles uh, in an easier format. So the first one says continuous delivery to satisfy customer with working product, which is what I've explained just a little bit before, just a while ago, that uh, customers would keep getting incremental updates or incremental project. So like they will get a working project every demo. So after every sprint, their product would be little bit more evolved. They will have more functionality, and customers will have chance to see it through demos. And then harness change for customer competitiveness in the market. Ah, yeah. So what this also does is like, uh, since we are giving a working product to the customer, and customer has options to see it. So customer is someone who has given us the contract to develop an application for them. So what if environment around the customer is changing? So whatever they have defined the scope uh, for their project before or the product before is changing now. So they will let us know based on the market that, okay, now we need this. So imagine like during COVID time, everyone were like building. So imagine someone would be building a store and an application for store, but due to COVID, everything had to go online. So that is like a market requirement at that point. So that had to be incorporated into the product. So now all the products which or like all the applications which we were building for those clients, now it would be more what we say front end or UI compatible, where people can come and place an order from their home and they get the delivery. So things like that. So we in Agile principles, we kind of harness the change based on the customers requirement. Third is we provide delivery to clients in subsequent uh, intervals. So we do provide like after every 3 or 4 weeks, whatever is decided, and every 4 weeks, clients will see or yeah see the product and they can play with the product as well. And in this principle, in Agile, business, QA, dev, they all work together. They have like a common understanding. They have like transparency and since they have the interaction with stakeholders as well. So there is no transparency between like the end users and these team members. So business, QA, dev, all this all these are like very transparent with each other, and they all have to be on same page. So they since there is no since there's transparency where everyone can talk to everyone, the misunderstanding is very less here. So this is one of the key principles. Thus, what does it provide? Agile also provides with the suitable environment and support that needs and team owns everything. Yeah. So because of all the three team members of software development are in one small team together, it does provide them like a good environment where team has all the help it needs, it has all the support it needs from everyone. And then Agile principle also says that it kind of motivates for team to be present in same location, under the same roof, to have like the same to have face-to-face conversation, which they find it to be very beneficial. However, this has been changing and been replaced after COVID by lots of team meeting, as in done through what do you say, online meeting. So face-to-face was not possible, but however, they tried to replace it with uh, Teams meeting online, because all the team members can't be at the same place or in the same office. Some offices have like a lot of branches. So one could be working from Toronto branch, one could be working from Mississauga branch. In those cases, online meeting would still be very beneficial. And then one more point is working software is of high importance. This has been the main goal of Agile. Nothing new here. The next one is sustainable development sponsors. Devs, QAs are working at constant pace. Yes. Here, there's one thing which, so as soon as we have the sprint, developers would start, uh, so sprint would have some user stories or use cases which they have to develop, right? Functionalities, I mean. So while developing that, the developers will go through those requirements and start developing or coding. QAs, on the other hand, would start writing test cases. So as soon as development is done, QA would start completing or start executing the test cases which they have written. So the pace is same for both devs and QA. So like they are all equally involved, and they're all working at like constant pace. Like it's not like development is slow or QA is slow. They're all on the same pace. So 1, 2, 3, 4, 5, 6, 7, 8. So 9. Ninth one is the art of maximizing the usage of software reusability of the code. So it says that if there is any part of the code which can be reusable, we would try to mostly reuse the course, or like some test cases which can be reused and which would help in faster delivery of the project or faster development and testing. So we would be using that. So we will be making use of the existing code in order to develop the product faster. And then the teams don't need to be here. The teams does not have to be monitored by a team lead or like a manager. Here teams are all like they are self-motivated members. They all have responsibilities which they will be taking care by their own. They don't have to be you know, they don't have to be pushed. And so yeah, they are self-organizing team members. uh, they all the team members, as in devs, QA, they all should be promoting collaboration, as in like they should be very transparent to each other. They should yeah, they should have meetings to understand any conflicts. And yes, and the competency, I would say it Agile requires high competency, because since we are kind of delivering too many things, like every 3 weeks uh, a project or a product will be delivered. So there is no time to relax. Like 3 weeks, you're developing an application, you're testing an application, moves to the next phase. You're developing an application, testing the application, move to the next phase. So you have to be very competent, and there is like regular growth and also teamwork, because you'll be uh, or not you will be, it's like it's good to learn new things and try to automate, like for testing prospect, try to automate as much as possible in testing phase of the software development lifecycle. And then yeah, it also says that there should be a teamwork, which again whatever I've been explaining for this point. It just says that all the team members should be highly motivated, should be collaborative, good team members, should have the mentality of growth in them. And yes, adjusting the way of work. I think this one would be the last that since we are coming from different places and different places, and like there'll be dev who would be constantly working on development side, the BAs would be constantly working on business analyst side, and QAs would be constantly working on testing side. So we have to understand how each and every team works, and then based on that, uh, we have to plan our work, and then uh, ask any questions or like deliver the things. This point is mostly for asking questions on like how do you work along with others. So like if there could be a BA who's like very rude, how would you work with them? So that way. So you have to be adjusting it, not you, as in like the entire team principle or the agile principle says that you should be adjusting, or like where every other team member can easily work with you. So it's something on that scale. So these are like the agile principle or manifesto. With agile values and principle, if a software development life cycle is following an agile methodology, they have to make sure that the the delivery process meets all these agile values and principles. If they don't meet it, then it's not easy to be following SDLC process with agile methodology. The next we will discuss is agile. So there are around three most popular processes. One is in agile, one is Scrum, the next is extreme programming, and then it's Kanban. So let's start with Scrum. Scrum is again mostly used. Um, and there is hybrid also. It's not written here. Let me write. So there's hybrid where people use some functionalities from Kanban, some from Scrum, and try to, get into a software delivery lifecycle uh, in an efficient way, in even efficient way rather than general Scrum or Kanban. So let's go with Scrum first. Before going into Scrum, I would like to explain what are the different roles which are present in Agile. And so let me first go with I think that comes before roles. And so first I'll explain some roles, because now I would be using some terms and those will all be same across all these processes. So roles, and then there are some ceremonies. So okay. And ceremonies I'll explain in why. Let's start with the roles. We have, as we know, we have development team, and they all consist of devs, QA, and BAs together. Then they have Scrum Master, and what this Scrum Master does is like Scrum Master will host the meetings every day in the morning. So it's called like daily Scrum meeting, or some people call it like a stand-up meeting where uh, or stand-up meeting, I would say stand-up meeting where uh, where either the Scrum Master, or I would say Scrum Master, or the head BA would kind of walk through. There's something called boards like Scrum board or Kanban board or Jira board, something. So that has like all the user stories. That's too much information. Okay, so just understand that like Scrum Master conducts a daily stand-up call where all the team members would join the call, team members being dev, QA, BA, Scrum Master himself, and they would be discussing on what the team did the last day, what are they planning to do today, and and are they having any hurdles in in whatever the work they are trying to do. So Scrum Master will kind of resolve all these issues what these guys are facing, be it like they don't have maybe access, so they will try to get the access. And Scrum Master also has to make sure that Dev, QA, and BA team members are following Agile methodology properly while developing, right?
Sure. Sorry, I have a question. So, or just like confirmation, so more or less, the Scrum Master is like a project manager, like in another sense.
Yeah, you can say that, but not exactly project manager. He has to, so he will be making sure that, all these team members are kind of doing their job perfectly, and they're also making, doing their job perfectly, and then
Okay.
making, what do you say? Yeah, they'll be doing the job perfectly and making,
Okay.
resolving all the hurdles which anyone is facing. So, and all are following agile methodology, so that is what it has. So project manager is something who would have like lots and lots of team under him, so or her. Like project manager is, imagine like they have like 5 projects which is going on at the same time, uh, and project manager, and there'll be like different team leads assigned to the project manager, where team leads will be taking care of like how projects are progressing and things like that, and they will report to the project manager. But Scrum Master is a little bit different. Here the Scrum Master's role is to just make sure that agile methodology is followed by the team is not having any hurdles, and agile and Scrum Master will also be responsible because there's something called boards, okay, and there's something called user story. So before even going more, let me introduce us something very good here, which is called user stories. STORIES, user stories. Okay. So what is user story? User story is nothing but all the functions which we have mentioned. So like creating an account or like building login page and things like. So those are small functions, right? So user stories are nothing but all these functions are written into user stories. So this becomes like a ticket. So function 1, login. So this is one user story. Then there'll be user story 2. So all these user stories, function 1, login, function 2, accounts, creation. So all these are like different user stories. And all these user stories would be present in a board, which could be Scrum board or Kanban board. I'll explain this boards later. And this will all have like user stories would have like some things called priority and backlogs. So let me explain them one by one so that you understand everything correct. Backlogs, to do, and ready to test, and done. So I'll explain this in 1 second, and then I'll come back to your question on what does Scrum Master do, so that we all follow properly. Backlogs. Okay. So to answer Adi's question, I'll go a little bit deeper into what happens in a project, like how this works. So Scrum Masters, so all BAs, what they would do is first they will have a business requirement document, that's fine. Then BAs would for every sprint, no, first is backlogs. Okay, so there is a board called Kanban board or Scrum board, which has like a backlogs. Backlogs is nothing but all the BRD requirements requirements are split into small epics and user stories. Okay, so what happens here is like all the requirements which are present in the business requirement document, what your BA would do, BA would go to application like call it Jira is one of the company who makes the application, or even Azure Dev. Azure also has one of the application where like all this user stories can be stored. So what happens in user stories? User story will have all the requirements of the functionality. So user stories will be of login will have one user story, account creation will have another user story. So similarly, like we saw so many functionalities. Everyone, all this would be in user stories. So user stories will have the functionalities. User stories will have functionality. It will also have accept entry and exit criteria. ITER, or you can say, yeah, entry and exit criteria. So a user story will have functionalities, plus it will have like once it will have the criteria like an entry criteria and exit criteria, which is like if a functionality is when the functionality should be developed, and once the functionality is developed, what are the requirements, or like exit criteria is nothing but acceptance testing. When do you say that this user story is completed? So once you meet a stage where like exit criteria is met, which is like acceptance testing is done, that means like the functionality is properly developed and tested. So all these functionalities, all these user stories have a priority assigned to it, and priorities assigned based on the based on users requirement. So if user wants like the login page to be created first, then this user story will take the highest priority. Similarly, if user wants like account creation of the product to be work second, then this would take the next high priority. So BA will be responsible for that. BAs will have all the BRD with all the functionality. They will break it down into user stories. They will assign priority based on what users want, and they will put them all into a place called backlog. Backlogs are nothing but it's like imagine it like a uh, imagine it like a folder which has all these small user stories present in it, and it has like a priority on how these user stories should be created or worked on. So I hope I'm clear on backlogs. I'll move on next. So once sprint planning starts, right? So all these are ceremonies. Sprint planning. So once sprint planning starts, what team members will do is like they will select some user stories from the backlogs, and then they will decide, okay, these are the user stories which are high priority and we have to finish in upcoming sprint. So that means like develop, test, and deliver in 3 weeks. The sprint planning, what to develop, test, and deliver in next next 3 to 4 weeks. DELIVER in next 3 to 4 weeks. Okay, perfect. So, Scrum Master will host all the sprint planning calls, all these daily meeting calls, and Scrum Master's work would be to make sure that priorities are assigned properly, and then developers are working on correct user stories. They are moving the user stories from stages. So user stories can be in all these stages. So these are the stages for a user story. So first they are in backlog. Once the sprint starts, they move from backlog to to-do. To-do is like the place where development is done, where developers know that they have to build this functionality. Developers and testers to know what user stories to develop and test in upcoming sprint. So it will move to in progress, where development will occur, then ready to test. Testing will occur. Testing is complete. Okay, so Scrum Master would host daily Scrum meetings with dev QA and BA, plus it will see all the user stories. They will see if Kanban board has the backlogs properly created, are the elements or the user stories moving from backlogs to to-do properly. In to-do, are developers working on time, and then are they moving the ticket or the user stories from to-do list to in progress list, and then once development is done, it's moving to ready to test. Testers are testing properly or not. So all these things will be taken care by Scrum Master. So they have to make sure that everything in Agile is being followed properly. But whereas project manager would have like lots of projects under him or her, and then he has to make sure that all the teams are working, all the projects are working, or are being developed on time, being tested on time, and things like that. They are not. They can be same people, but they should not be same people. If you know.
Now I understand. Yes, thanks. I understand.
That's done. Do you understand?
Yes, I do.
Okay, perfect. Oh, okay, now there is something called product owner. And product owner is like a stakeholder represent Okay, a stakeholder representative who communicates the vision. Okay, so product owner is a person who would own the product. So he's the person, or she's the person who would imagine what the product would look like, and what the product should uh and what is the product which they want uh, all these team members or development team to work. So this is the product owner. And after completion of any sprint, we have to give a demo to product owner, and product owner in turn would decide whether everything is fine or not, and things like that. So Any questions on the team? So agile roles. So these are the 3 roles. And next we will move to ceremonies. So ceremonies have daily Scrum, and daily Scrum I have explained you a little while ago, which is like everyday morning Scrum team meets, Scrum team as in like all dev, BA, QA, Scrum Master, product owner, they all will meet for like 10-15 minutes over a call, or if they're all present in an office, then they will meet up internally, where quickly they will go over the Kanban board or the Scrum board, where they will see uh, the items which are in to-do list, how are they progressing. So these are like the different user stories. So user stories in to-do list, how are they progressing? Developers are working there or not? If developers have any issues, then they will mention the issues in the call. And Scrum Master has to make sure that those issues are resolved before, or those issues should be resolved at high priority, or else there might be a delay in project delivery. Okay, so that happens. Then there is sprint grooming, daily Scrum. I can just say daily stand up call with the team hosted by Scrum Master. Okay, and then I'll say sprint planning, but before sprint planning, I said, okay, sprint planning. Sprint planning, we are aware of what it is. The next is sprint refinement or grooming. So in this, Scrum team members should understand the requirements better. So what happens here is like after planning is done, then sprint refinement or grooming happens, where Scrum team members understand the requirements. Yeah. So where Scrum team members understand the requirements better, and there are some times where one functionality. So imagine that there's a functionality which was calling, right? Calling functionality is very big, and it can't be completed in one sprint. So it can't be the development of calling could not be completed in like uh, 3 or 4 weeks of time. So what they do here is they break this functionality. If anything, or if any ticket which is not, or any user story which can't be developed within 3 to 4 weeks, has to be split. And that is called has to be split and should be developed in different phases. So first phase, half of the ticket, half of the user story would, or like half of the epic would be delivered, and the next one half will be delivered. So epic is like functionality. User stories is like breaking down of these epics into small parts. So those will be like user stories. User stories can be without epic also, but it's always better. It is like realize that if there's a bigger functionality, then they will have like big functionality put into epic, and then they'll have small user stories which will have like part by part. So example for calling feature would be like audio calling, video calling, so like two different parts. So they will split it into two user stories and link it to the epic in the Kanban board. I don't know if I can show the Kanban. I don't have as of now, but if I could, then I'll try to show a Kanban board in the next session, where you can uh, visualize everything. But or else, like you can still go in YouTube and check out how Kanban board works. But all the terminologies would still remain the same. And then finally, we would be doing sprint retrospective. What happens here is this happens at the end of the sprint. So sprint planning happens like before even the sprint starts. Sprint refinement happens during the sprint or like just one day before the sprint. Daily Scrum call takes place every day. Sprint retrospective is done at the end of the sprint or after the end of the sprint, I would say, after the end of the sprint. And in this session, team goes over like what did they do good, uh, and then what can be done to improve the process better. So they take like feedback from every team member. Feedback received and noted. After every sprint. Why this is required? Why do we need retrospective? The main reason for having retrospective is at the end of the sprint, there could be some issues which team has faced in this 3 to 4 weeks. There could be some hurdles which this team has faced. So what they would do is they would note down everything in a document, and then they will try to resolve those issues up ahead or like well ahead in time in the upcoming sprint. So that way it helps the team to make sure the same issue is not occurring again and again. And if there's any problem with the team members or something, then this is the place or this is the call where everyone would uh, come forward with their feedbacks and uh, have it noted down to be worked on future sprints. So these are the ceremonies. Did I miss anything? Okay, I think I have covered all the ceremonies, different stages of user story and roles of Agile, plus, yes, so all these things are covered. Now we can happily go and jump into processes of Agile. So now all these processes would be using all the things which we just learned about Agile, right? It would be using the boards, it would be using the development team, Scrum Master, Product Owner, all this part. So let's start with the Scrum process. I have very good stuff. Okay. For Scrum, in Scrum team, the roles would be there'll be Scrum Master, Product Owner, Development team. Roles have defined responsibilities and interactions. Uh, Let me copy over this point so that I can go over them. Okay. Okay. So roles, Scrum process has roles of Scrum Master, Product Owner, and Development team, and each member has been assigned with their roles and responsibility, and they have to be doing that. Iterations, all the Scrum processes are of fixed length. It can't be more than 2 to 4 weeks long. It has to be under that. So if there are functionalities which would take more than 2 to 4 weeks, either the functionality has to be broken, which is like user stories has to be broken, or uh, the yeah, I mean there's no either. The user stories has to be broken and put it into half and half. And in iterations, sprint planning would occur, daily stand-up meetings would occur, sprint reviews would happen, and sprint retrospectives are their key ceremonies. So those things will happen in Scrum process. Moving to artifacts, it will have like a backlog, which I was mentioning above. So backlog is nothing but it is a prioritized list of features and tasks, which is nothing but user stories. And then it has like a burn down chart, which is like, which also means that when so if there is a user story which is present in the burn down chart, it will say like how much amount of work is done, how much amount is completed, and how much is pending. So visualize the work completed over time. So it will show how much of the ticket is completed and how much is pending. And prioritization is done based on uh, based on the stakeholders first and how much amount of work a team can do for the upcoming sprint. So like if there are like 3 developers, so 3 developers can build like only 2 functionalities, then only those 2 functionalities will be moved from backlog into to-do stage, and then they'll work on that. And change management is very good. Like change management means change to the scope are discouraged during sprint to maintain stability. So during the sprint, there will be no changes. Whatever is selected, those will be developed and delivered. However, if there is a change required after or while the demo, then those change will be documented in user stories and could be incorporated in future sprints. So those are the things about the Scrum. We will move to Kanban. Are we clear about Scrum? So whatever I was explaining before, they are all with respect to Scrum. So it's easy to follow through and it's easy to understand. However, if you have any questions related to Scrum, you can let me know right now.
Sure, just to confirm,
Hmm.
under no circumstance can a sprint be longer than 4 weeks?
Sorry?
Like all the sprints they cannot be longer than 4 weeks. Like that's a month.
Yeah.
Like each sprint.
Yeah, each sprint cannot be longer than 2 to 4 weeks. Correct.
Okay.
It should not be smaller than 2 and it should not be longer than 4. If it is longer than 4, then they will split the user story and deliver it in the next sprint.
Okay.
Okay. Then we have Kanban. So it is very similar to Scrum. However, in Kanban, there is no. Hold on, let me first fix that. Okay. So roles are less. And in Kanban is like little bit more flexible compared to Scrum. Team members often have more flexible roles. So like uh, there is no defined Scrum master here. A stakeholder or product owner can take the call or do the calls if required. And then iterations are not of uh, defined length. In Scrum, we had like 2 to 4 weeks, but in Kanban, there is no iteration or like sprint uh, defined. So imagine one sprint can be of 3 weeks, the other can be of 4 weeks, the next one can be of 5 weeks. So it is on the functionalities, I guess. It's not based on the time. So this is Kanban process where there is no fixed iteration, work is continuous. But however, the Kanban board will be very similar to uh, the board which is in Scrum, but it will have a different flow. That's it. The board will look alike, just a little bit different flow, as in like what are the stages or what will the stages of a user story be. Yeah, here in Kanban you see some boards as in like I don't have a pictorial graphical representation, but I can do one thing. Let me do a paint and show a little bit how this looks like. So in Kanban, all the user stories will be present in to do first. So like to do once at the before or like before the start of the sprint, and then once the sprint is in. So if a developer, imagine that there are 3 developers and there are 5 of these, so they move, like if each developer is working on one of the user stories, they move the user stories from here, from to do to in progress first. So all these user stories will move from here to here, and then in progress they would write the coding, or they will do the coding. So they'll finish the coding, and after coding, the same user stories will be moved from in progress to testing. So this is the process it will follow. So it will have like a backlog. Backlog is nothing but like a very big, which with list of all the user stories. It will have user story 1, 2, 3, 4, 5, 6, and like everything what is written in BRD, right? And from there, we will choose some of the user stories, put it into to do, and then take it from there. Is this clear? Like, I don't know if this is not very good, but this is how it would be. So all these lines are maybe user stories, and then it will move this way. And after testing is complete, we would say that the user story is done. So final stage would be done. So this is how the Kanban board will look like in real life. Just the user stories will move from here to here, here to here. And like every time you open a user story, there will be like a stage where you want to put, where you want the item to appear. If the stage shows to do, it will appear in to do list. If you choose progress, it will show in progress. If you choose testing, it will show testing. If you choose done, it will show in the done stage. So it will look like something like this. Let me go back. Differential cumulative workflow provides insight to the workflow over time. So work prioritization, work items are pulled as capacity allows. Yeah. So the only difference between Scrum and Kanban is like if for Scrum it has to be like 2 to 4 weeks, nothing beyond that. But in Kanban, like even if a user story takes 5 weeks, they would use it, and then they would make the next sprint for 5 weeks instead of making it 4 weeks. And change management, it embraces the change and allows for flexibility in responding to new priorities. So the difference again here is like the change management. In Kanban, if there's a change from the user side or like anything, it will be incorporated into the same sprint. The changes will not wait until the next sprint. So that would be one of the differences between Kanban and Scrum. Coming to, so this is all about Kanban. Now coming to extreme programming. So extreme programming is again very similar to this. I'll not go too much into detail with extreme programming because no one kind of uses extreme programming a lot. So I'll quickly go over some of the points of extreme programming. So roles wise, there is a lot of communication and collaboration between the team members, and there is still no roles as like Scrum or yeah, Scrum as in like no Scrum Master or product owner or anything like that. Entire team shares the responsibility, just same as like Kanban. Their iterations are short development cycle, often 1 to 2 weeks. So extreme programming is very short, only 1 or 2 weeks, not beyond that. And their key practice is like integration. So integration as in like they make a small product for like 2 weeks and then they integrate with the previous one. So make 2 weeks product integrated with the previous one. So that's what the strategy they follow. So which is called continuous integration. It has user stories, short and simple description of features, uh, so that any user can identify. So the user stories will not be like very complex to understand. It will be very easy written. Um, and they have a release plan which says like what are the features which are prioritized and what are being delivered uh, at the end of the sprint. The final would be work prioritization, which is all like for all agile work prioritization is mostly on the customer or like the end user who would say, okay, I want this functionality first or not. So work prioritization still remains the same for extreme programming, and even extreme programming embraces the change and encouragement for feedback and feedback from customers. So it is very close to Kanban. I would say extreme programming. The only difference is uh, from Kanban is like it's 1 to 2 weeks of cycle, and it involves continuous integration. Continuous integration is nothing but like you develop in 2 weeks and uh, then you integrate your newest development with the old development, like whatever was developed earlier, and keep integrating and keep developing software in very small incremental cycles, I would say. That's it. So these are the different agile processes. I have mentioned all the points here just in case. Okay. At this point, I think we are done with complete agile. Now we kind of understand what is agile and what are the different processes in agile and different roles in agile, different ceremonies in agile, and yeah, I hope now we are very clear with what agile is.
Yes, yes.
If is there any question on agile? If no, then I'll move ahead with fun stuff.
No, no problem.
Problem? Okay, let's go ahead with the next part, which is test design techniques. So this is very interesting topic. So yeah, we'll be first learning about what are the different techniques. So there are two types of uh, techniques. One is like black box testing, and the next one is white box testing. So what happens in black box testing? So let me tell you where did this go? Okay. How to make this go? Okay. So consider black box testing as something where this is the product, okay, or the application, where you provide an input, where a user or tester, so I'll say test or QA, to be honest, or QA resource would provide an input to the process. So QA user would provide an input to the application. Application would do some processing, like processing could be anything. So application will do some processing and then will give us an output. So here we can see that what processing did application do? We will not be knowing. So that is why it's called black box testing. So for an example, you open your application, or if you take your phone, you dial the phone number and you press on call button. The calling happens, right? So you don't know how or what programs are being executed in the background, uh, how a call is done, what and all is happening, you have no idea about. And that is what black box testing is. So like you don't have to know what the application or like what are the programs which are being run in the backend or like in the server. You just have to concentrate on input and output. So you're giving an input, application is doing something and it's giving you an output. So you have to just validate whether for each input you're giving, you're getting proper output or not. So for every input, you are getting proper output response or not. So that is black box testing. Coming to black box testing, it has there's different ways of doing the testing. So which is let me show you here. Okay. So it is specification based, and the techniques is input and output testing technique. So you provide some input, you verify the output, and you don't have to know what the software is doing. And some examples of black box testing is equivalence partitioning, boundary value analysis, design table, no, sorry, decision table, state transition, and use cases. We will be covering this in just like 5 more minutes. We have it here. So we will go through each and every point from here and understand what is black box testing. So this is all about black box testing. Now next is white box testing. So white box testing is opposite of black box testing, which is like here. So for black box testing, like anyone can do black box testing. They don't have to know anything about coding or nothing about programming or inside the application. So they can do it with the help of just running the application as in like providing inputs and getting the output. Whereas black box testing is a little bit different. In black box testing, you need to know the internal structure of the software, where like you see the software. You have to uh, like white box testing is mostly done by developers. So they have to make sure that uh, they do unit testing, which is through by first making sure all the code, all the lines of their code is executed, all the decisions. So like they have some decisions which you would know when we start our automation testing classes. You will know that there is like if statement, while loop, do loop, so all those things. So like in white box testing, a developer would do unit testing, which would be like they would do they would run all the lines which they wrote in code first one time. They would test all their conditions, they will test all their loops, and they would test all the workflows. So that is what they would be doing, where a person to do those testing should have programming knowledge, should know how is the software designed, and things like that. So those will be done by developers. But again, white box testing also involves like static analysis, which can be done by testing. And we will go over these in some time now. So let's start with equivalence partitioning testing, and which is actually black box has some more equivalence partitioning testing. I'll have some examples here. Let me know if you can see my screen or the presentation. Can you see the slides right now?
Yes.
Okay, perfect. So we will start with boundary value analysis, and then we'll move to equivalence partitioning, then decision table, and then state transition. So first is boundary value analysis. So today in the morning session, I was telling, like, if we want to test an field in a web page or in an application which tells user to input some numbers, right? Maybe from 0 to 99. And what our tests would be, like, we will be, as a human being, we have to test. Actually, it's a good question which I can ask you guys now. Like, given a field which takes an input from 0 to 99, what are the different numbers you guys would be testing the field for? So, like, imagine that there's a field which says uh, enter a number between 0 to 99. And if you enter any number which is either less than 0, it will say invalid number. And if you enter something greater than 99, it will say uh, input value is higher. So what are the different types of testing you can do for for this field? If you can give me examples of like few, it would be really good.
You can try testing numbers actually between 0 to 99 to make sure that it accepts it.
So how many numbers would you be testing from 0 to 99?
Maybe 10 or 15.
Maybe 10 or 15. Okay. Would you be doing any other testing?
Yes, you can you can test for string values as well to see if it takes it in.
Oh yeah, that's true. That's a very good scenario of, like, negative testing, that invalid scenario that you should not be accepting any characters. That's true. So that is two. Do we have more? Tommy, Selim, anything from you guys?
Well, no decimal place, or I don't know. I think it's what Marcel mentioned.
Sorry.
No decimal place, or I don't know, like maybe for 20.2, or like as you said, no strings, or
Oh, decimals you're saying?
yes.
Okay,
Yes, I
so
don't know if that makes sense.
decimal is also one of the case, obviously. Yeah, that's
Yeah.
true, which is a good case. Anything else? Okay, let's yeah,
You
go ahead.
can also test for null values. That is, try not inputting anything to see if it will actually take it as well. So
Yeah, that's
I don't
a
know if that.
good case as well. 100%. Yeah, that's nice. Uh, okay. So we did say, or we say that we came up with, where's my notepad? We have a field which accepts numbers from 0 to 99. If less than 0, print invalid number. If greater than 99, print invalid or number can't be handled. Anything between 0 to 99 is print good number. So we got answer from Ansel saying that we will test some 10-15 numbers, 10 to 15 numbers between 0 and 99. And then we got like string, we got like we got decimal. Okay, so all these are the cases, but in real time we would be testing more, as in like we would have to test all the conditions. So like 0 to 99 is like a very valid condition, right? Valid test case. But then you have to also test this part where what if number is less than 0? You have to test this part, right? Uh-oh. What happens if your number is less than 0? So you have to test less than 0, and then you also have to test greater than 99. So these are all valid scenarios. But now the question is, how many numbers less than 0 should I be testing? So should I be testing 0, -1, -2, -3? It will go up to infinity, and even positive, it's like 99, and then if you put 100 up until infinity. So there are like so many number of test cases. You can't run so many test cases, right? So to do this, to get defined answers, where like a minimal testing to do, where we achieve 100% testing, we came up with, or like people came up with something called boundary value analysis. So what boundary value analysis says is, if there is a boundary, then you test one number before the boundary and one number after the boundary. So that's what it says here. So if you see that this field accepts age, which is 18 to 56. So you would be, so age, so you would be testing like 17. You would be testing 18, obviously. You will be testing 19. Plus, this is on the left, or what we say, this is on the lower end. And you would be testing like 55, 56, and 57 on the higher end. So for our example, it would become that we would be testing for boundary value analysis, we would be testing -1, we would be testing 0, we would be testing 1, and we will be testing 98, we'll be testing 99, and we'll be testing 100. By doing just 6 tests, we will achieve all the tests efficiently. Again, these two are separate. These are like special scenarios, and this has to be tested. So this is there. But however, so imagine like, so if -1 is giving you the invalid number error, if -1 gives you invalid number error, so what does this mean? It's like, if -1 gives you invalid number error, that means that any number like before -1, like -2, -3, they will all give you invalid number. And if, or like 0 would also give you invalid number. So any number, oh sorry, it accepts 0, so 0 is fine. So, and any number between 0 to 99 will all be pass, and any number 100 or 100 above will give you an error. So this is what it means. So boundary value analysis, you don't have to test like 10, 15 numbers. You have to just take one number before the boundary, one number after the boundary, plus the boundary value as well. Similarly with in both extremes, not just one side, you have to make sure both the extremes are possible. Okay, so let's take one more example where I would need input from the team, where a field which takes input from maybe like 10 to 55, what are the boundary condition you will test? what are the boundary values you will test? So there's an input field which accepts values between 10 to 55. So what will you test here?
So you test 9,
Okay.
10,
Okay.
11,
Perfect.
and you test 54,
Okay.
55,
Mm-hmm.
and 56.
Okay. That's perfect. This is exactly what I wanted. So did everyone understand how did we test and how these numbers come up?
Yes.
Boundary value analysis is okay.
Yes.
Okay, perfect. Let's move on to the next one, which is equivalence partitioning. So what happens in equivalence partitioning is like we kind of divide or like we partition the input lines into valid and invalid options. So what we do is, let me take paint. Uh, so 0. Okay. So let me take this 1 and here it is 0 and here is 99. So this is a scale which starts at 0 and it has 99. And consider it to be a field which takes values from 0 to 99. So what we do in equivalence partitioning is we kind of divide or partition values into valid values and invalid values. So for this section, this part, this complete part from here to here is valid, right? So it's like valid. And anything beyond is invalid. So here it is invalid. And all this part is invalid as well. Okay. So what equivalence partitioning says is first try to divide your inputs into valid and invalid sections. And from each section, take one value and test it. So from invalid, I can take any value. So I can take -5, -6, anything, just one value. From valid, I can take one value, which I can take 1, 2, 3, 4, 5, up to 90, any one value. And from this invalid, I can take one value, which is like 100 or like 101, 102. So from valids, I'll be choosing. So from each section, I'll choose one of the options. So I'll choose one of the options from here. I'll choose one of the options from here, and I'll choose. By doing that, I will attain 100% testing if that is passed. So if my -1 fails, that means this entire section is tested. Uh, if my 1 as an input, or like I would say 1 as an input would test all this part from 0 to 99, and 105 as an input would test all the invalid scenarios here. So equivalence partitioning says like divide the inputs into valid and invalid scenarios or sections and then test one value from each section. Are we clear on this?
Yes, for my
Yes.
quite clear.
Perfect. So now it's time for you to answer one question, which is, let's take this one as an example. Okay. Just a minute. Person with age 18 and below between 18 and 30 are eligible to yeah. So what are the three scenarios or like three valid cases? Or like what are invalid sections and valid sections here?
Invalid should be people less than 18 and people older than 30.
So less than 18,
Yes. And more than 30.
sorry, I can't hear you. Can you repeat again, please?
More than 30 years.
Okay, more than 30 is valid. That's perfect. And valid would be give one example of valid.
19, 20.
Okay, so you just have to give one because we don't have to. So testing one valid would kind of test everything between this. So that is equivalence partitioning. Or yeah, so that is equivalence partitioning. And after equivalence partitioning, you need to know that you have to test only one value. So that is important part. Equivalence partitioning everyone can do, but the process or like the thing which everyone forgets is like you have to take only one value, not all. And now, if given a place where you need to uh, test a field, you would use a combination of boundary value analysis with equivalence partitioning and decide it and try to come up with an efficient number of test cases or efficient number of inputs rather than testing like millions of inputs, right? So these are the two things which you would be using. Now moving to the next topic. So quickly, I'll try to cover some topics today, at least like white box testing. We are very nearby, so just give me like 5-10 minutes. I'm a little bit beyond 4. So give me like 5-10 minutes and then I'll finish at least like black box testing and then we can continue on next weekend. Okay. Is that fine with everyone?
Yes. Yes.
Okay, perfect. So next is like decision table testing. What happens? Sorry. Okay. I think I heard someone, but however, I'll continue, which is next is decision table testing. What happens in decision table testing? We kind of create different combination of inputs, okay, and then try to execute that. So for test case 1, so imagine that there is a cause and its effect. So like this is a decision table of cause and effect. So what happens is condition 1, account already exists, OTP match, sufficient money in the account. So these are the three conditions. Then action would be like transfer money. Okay. So if all the three conditions are met, we will take one action. So if account already exists or approved, OTP is matched and sufficient money. So these are like true. All the three conditions are true. I would transfer the money. But similarly, if account is approved, OTP is matched, but there is insufficient money. So this condition, if this is false, then it can't transfer the money. If it transfers the money, then it might go into negative. So in those cases, there will be a message shows like show message insufficient funds. So even though you are approved to log into the system, OTP is matched, but since you don't have money, you can't send the money. So action number 2, it will display. So insufficient money will be displayed. The third is you have approved, you have account money in your account, but OTP does not match. So that means someone has got hold of your email ID and password, and you have money in your account, but since they don't have your phone, they can't get the OTP, and hence the action 3 will be triggered, which is like block the transaction in case of suspicious transaction. Third is someone has your account, they don't have your OTP, and they don't have even money in your account. Then what happens? Then it will say again the suspicion transaction is found. And the final would be that account is not approved. So if this is false, the other two won't even happen. So what would happen that time? It will again say that actually it would not even let anyone go to the system. So that would be like test case 5. So there are 3 conditions and 3 actions. So how are you going to test this action? So you have to decide this by drawing a table first, which will say all the 3 conditions, like account already exists and stuff like that. And then when all the conditions are true, what will happen or where the flow will go. So that is executor. So that is decided based on the decision testing table. So you create this table where you try to give inputs based on true and false, and then say what will be the output. So that is decision table. Now I'll move to the next page, which is, this is one more example which says, so the condition is like cash or coupon. If you say cash, then order is placed. If you say no cash, but coupon yes, then the order is placed again. And if both are no, then order is not placed. So this is again one of the conditions or one of the decision table where a order will be placed if you pay by cash or if you pay by coupons. So what are the different options which you can use to test? So first you will draw this table. You will write like a cash and coupon, and then first you will put like, okay, cash as yes. If you have cash, you don't need coupons NA, and then order is placed for you. The second option or the permutation would be, if you don't have cash but you have coupons, then you can still make the payment. And third is like, if you don't have cash or coupon, then order can't be placed. So all the 3 scenarios you have to test using the decision table. So final one is state transition. State transition is very simple, most probably used while transitioning from one state to another. So one transitioning could be in login page. So when you try to enter your user ID and password, you click on submit. If the credential is successful, it will let you pass. So that is like straight transition. So you transition from one screen to another. So what would happen? So for this example, it's like state 1. So what is the state 1? You're trying to enter correct ID and correct password. Sorry, here they are trying to enter correct password and incorrect first attempt. Correct password, incorrect password. Okay. Oh, so here they are just mentioning where the flow will go. So here is the home page. And so imagine that there's an application. This yellow things are nothing but someone is trying to enter a user credentials. And if the credential is matching, then it would go to home page. And if it's not matching, then it will say, okay, user ID and password didn't match. Please try again. So a second attempt will be tried. Even if second attempt fails, it will go for the third attempt. But however, if second attempt pass, it will give you the access. And similarly, if third attempt fails, then it will lock your account. Third account passes, it will go give access to the home page. So how we do this is like, first we will try first attempt, and then we will write correct password, what will happen, incorrect password, what will happen. So From first attempt, correct password will give you access to the home page. Incorrect access will take you to the second attempt. So S1 is the current state and S2 is the second state. So we mark all the states with an option first. So this is like first state S1, this is second state S2, third state S3, fourth state is F4, fifth state is F5. So before even making this table, we will mark all the states and then try to do different permutation and combination. In real life, we hardly use state transition, to be honest. We would most widely be using decision table and boundary value analysis for testing or equivalence partitioning for testing. So state transition, we should just know what it happens or what happens. So it's like if you do like imagine with the login button, you will either given access to the system or you will be thrown an error saying that user ID and password is right or wrong and do the second attempt. So transition is just like what are the stages or what are the different state an application can go, and you have to test all the states. So like if there is like to identify that your account is logged or not, so you have to purposefully do this testing because to make sure like if you enter your password 3 times wrong, your account has to be logged. If it is not logged, that means the system is not working fine. So very important. I mean, I'll not say very important. This is tested very minimal, but it has to be tested. Everything in the application has to be tested. So to test any login or state transition, we can use state transition table to test that. Use case I will cover in next session because yeah. As a part of white box testing, I would go through some of the static testing, which is nothing but what happens in static testing is like you will be going through or like reviewing a document. So BRD kind of like business requirement document one a business analyst gives you. You will try to find issues by reviewing the documents. By reviewing the documents, I mean is like you'll go through each and every section of the BRD or the functionality. You will review, try to find for the mistakes and like what are the potential issues while reviewing. It could be anything, even it could be spelling mistakes. It could be like functionalities not spelled or like not listed properly. So if you're not understanding it clearly, then you can you can find those mistakes during reviews. And then there would be walkthrough. Walkthrough is nothing but what business analyst, once they create the BRD and they got it approved and reviewed and everything, they will gather all the team members like QA and developer into a call, and then they will say, okay, this is the project which we are going to develop, and they give us a walkthrough session. So walkthrough session, they will walk us through the BRD document. They will say each and every section and what functionalities are being added into the project and things like that. The final is inspection. What in inspection, you just skim through the document, try to find any issues or any problems which could be of potential issue and try to flag them and get it corrected. So this static review is nothing but a verification part of V model where you just go through the documents and try to find issues, as much as issues as possible to get it fixed and for everyone in the team to have same level of understanding about the documentation. So that is static analysis. I think we have kind of covered almost everything here, except use cases. I will cover these use cases in the next session. What are yeah, so I'll cover these use cases in the next session. For this section, for part 2, we discussed about different processes of Agile. What is Agile principles? Then we went ahead and discussed something about Black box testing and white box testing. Black box testing is non-function or like functional testing. White box is where in white box we are going to do some static analysis, which is like how we test the application by reviewing the documents and by inspecting and going through walkthroughs. So that happens in black box testing. We understood about equivalence partitioning, boundary value analysis, some decision table, state transition table. We are left with use cases, which we'll do it on next week. And that's it for today. Do you have any questions on any of the topics which we went through? You can definitely let me know either today or like even later when you're going through the notes or going through the videos or anything.
Everything has been understand everything from my end. Thank you. Sure.